Итак, всем добрый день,
All right.
друзья.
Good afternoon, all.
Рады вас видеть на
It's
первом дне
great to hear all of you at this
Мы очень
first
рады,
day of
что
AI Journey.
а,
We're all very
мы
glad
запустились
that we have been able to
и в
launch.
этом году AI Journey бьет все рекорды.
This year, AI Journey has been
К сожалению, пандемия
breaking
внесла
all
свои
records.
коррективы, и
Unfortunately, the pandemic
не смогли
has
с вами собраться в
made
оффлайне,
its own
но онлайн
adjustments.
тоже имеет свои прелести.
We can't gather online,
Надеюсь, меня видно,
offline, but
слышно.
then there
Меня
are
зовут
certain
Андрей Черток, я буду
advantages
сегодня
in
модератором
online. Hopefully,
сессии.
you can hear and see me. My name is Andrei
Искусственный
Chertok,
интеллект
and I'm
Сбер,
going to moderate the session
Data
AI
Science,
in
искусственный интеллект в
Sber,
Сбере.
or
И
data science and
Сбер
artificial
сейчас это
intelligence in
уже
Sber.
не только
Sber
банк.
today is
Вот, наверное,
much more than a
многие из вас
bank.
видели, что мы, в общем-то,
You
произошло
may have
обновление этой
noticed that we
большая
rebranded, and
экосистема.
Sber is a huge ecosystem.
В общем-то, тема искусственного
And
интеллекта в этой экосистеме,
the
она
topic of artificial
становится
intelligence
одной из
in this
ключевых
ecosystem is
сквозных
becoming
технологий,
one of the
которые должна
cross-cutting key technologies
покрыть, в
that
общем-то, все
will
компании экосистемы.
have to cover
Я, прежде
the
чем
length and breadth
перейти
of the
к нашему
ecosystem
докладчику,
companies.
сделаю
Now,
небольшое
before I give the floor to the
со
rapporteurs,
своей стороны.
I would like to make an
Я вообще в
introductory
Сбербанке
speech
занимаю такое
myself.
подразделение, которое
In
отвечает за
Sber,
развитие
I
искусственного
work in the
интеллекта.
business unit that is in charge of
И ваша
developing
вот
the
буквально
artificial
пару
intelligence.
слов
And
о цифрах,
just a couple of words,
что такое
just a few figures on what AI is in Sber.
Соответственно, если мы попытаемся в цифрах, ключевые цифры
If you look at the
обозначить,
key
то
figures, then
сейчас в Сбербанке, в Сбере
right now
более
in Sber,
1500
there are over 1,000 data
аналитиков,
scientists and data analysts,
и это распределенная
and this
численность.
is a distributed figure.
Наши дата-сайентисты,
Our
они
data
сидят
scientists are
в самых
sitting
разных бизнес-блоках, сидят в командах, которые
in all
делают
kinds of
продукты, которые
teams, in all
делают
kinds of
сервисы.
business
То
units.
есть управление этим
They
ресурсом
are doing products,
децентрализовано.
they are doing
Мы же
services, so we are
отвечаем
managing this
в Сбере за
resource in a
развитие
decentralized manner.
Data Science Community,
Whereas
так
in
называемое,
Sber, we
и
are in
приняли
charge of
решение, что
developing the
будем
data science
развивать
community.
Data Science функцию вот в таком
We thought that
распределенном
we
режиме.
develop this data
Поэтому мы
science
сейчас, на
function
самом деле,
in a
даже точные
distributed
цифры
fashion.
можем и не
So
знать
actually, this figure
по
might not
каждого
be
человека,
exact,
потому
the figure
что
that I gave you. We
очень
might not be
активно
able
Сбер
to give the figure exactly for every
развивается,
individual
расширяется,
that has been
и мы
hired.
обеспечим такие
Sber
горизонтальные
has been
связи
actively
между
developing, expanding, and we
нашими
are ensuring these horizontal
дата-сайентистами. Но мы
connections
ведем
between our data
такой
scientists.
как бы учет, скажем так, да,
We are
сколько
sort of
у
keeping
нас
track
различных инициатив. Вот
of
сейчас
what
больше
initiatives we have.
1000
Right
различных
now, there's
проектов.
in excess of
Конечно же,
1,000
то,
various
и те
initiatives
проекты,
and
которые
projects.
вы услышите
Those
сегодня, это лишь
projects
малая
that are going to
часть
get
того,
mentioned
чем сейчас
today are certainly a
занимается Сбер.
small
На это бы не
fraction of the
хватило
things that Sber is
даже
doing.
такой сессии, как сейчас.
Even this
Потребовалось
session
бы
would
несколько
not
дней, чтобы рассказать, чем
be able to
занимаемся
cover
мы
the
в
length and
Сбере.
breadth of
Ну и,
them.
конечно же, мы занимаемся этим
It
не
would take
просто потому,
a
что
day or
это
two.
модно, классно
And we are
идет
doing this not just because it's fashionable and
ожидаемый
great.
эффект от
The effect,
внедрения
the expected
искусственного интеллекта
effect
в этом
from
году, он
implementing AI this year
ожидается, что превысит 60 миллиардов рублей.
is about
Это
60
достаточно
billion
существенная
rubles, and
цифра, то есть
this
это
is a
продукты,
considerable amount.
в которые
So these are
внедряются различные
products
модели,
that
да, искусственного
models
интеллекта,
get
и,
embedded in,
соответственно, мы пытаемся посчитать
that
все
AI
эффекты.
gets embedded in. We are
Это, к
trying to
сожалению, не
calculate the
всегда можно
effects.
делать. Это
This is
отдельная такая тема
not a
интересная.
possible, not a
Но можно
uniform
видеть,
possibility at
что
all times,
сейчас
unfortunately.
концепция ИИ в каждый процесс, в каждый
But we can
продукт у
see
нас
that the
очень
idea to
серьезным образом
introduce
развивается,
AI into every
расширяется.
product and every
Ну и,
service,
конечно же,
that has been
вот
expanding.
я здесь должен сказать еще
And
про
certainly I have to
AI-платформу. Мы в
mention the
2018
AI
году приняли
platform.
решение о
In
том, что будем
2017, we
создавать
decided
единые
that we
платформы,
create
платформенные решения, которые
single
будут
platform,
переиспользоваться в
platform
банке для
solutions that are going to
создания
be
новых
reused
продуктов, да, или каких-то
in the
новых,
bank
новых
to launch different
сервисов.
products and
И,
different
ну вот для
services.
примера мы посчитали,
Now, for
сколько в
you
банке
to
было команд,
understand,
которые занимаются чат-ботами. Это
the
порядка,
chatbots in the
казалось,
bank are
30
done
разных
by
команд, и
about
каждая
30
делала свое
different
решение.
products, and
И,
every
в общем-то, было принято
team
решение, что нужно создать
would
единую
pursue their own solution.
NLP-платформу, так
So we
называемую,
decided to put together a
на
single
которой
NLP
можно
platform
делать
where
чат-ботов.
you
Сейчас
would
нет ни одного
do
там ассистента в банке, который бы
which you
не
would, tweak
работал
and hone every
на этой
which way you
платформе.
please.
Ну и,
So there's
конечно же, у
no
нас
no
серьезная
team that would
достаточно
not work on this
история
platform right
с
now. Everyone does.
исследованиями, со
And we
статьями. У нас
obviously
есть
do
лаборатория,
serious
у нас есть
research. We've got a
прототип
lab, we
кода,
publish articles,
и
we've
уже
got
130
R&D inside the
статей
banks, we have published
и
over
различных исследований
130 articles and various
опубликовано.
research
И
papers.
такие мероприятия,
And
как сегодняшнее, мы, конечно же,
events like this, we obviously invest heavily in developing these. We are trying to put together new formats, not just hackathons, meetings, and keeping the regular proceedings of communities. We are trying to connect externally. As for the streams, we decided for ourselves that the topic of AI is going to be broken down into several areas. This is not a hard division, that's just our approach, that's our vision. And this list, actual list, is a bit different from the one I'm showing you. The message that I'm trying to convey here is that we've got several streams of activity, language processing, speech analytics, computer vision. We do have a graph platform. I'm not showing it today. We have a data labeling platform. There's a document recognition platform, IADP. And every platform of these does different products. And I'm just giving you examples. This is not an exhaustive list of products. I told you it's over 1,000 various initiatives. The point is that we are trying to pursue all these key areas, even at the stage of R&D. We are trying to catch up with the state-of-the-art models and approaches. And we are trying to prototype as quickly as we can in the bank. Here's an example of various prototypes, where we use certain experience, international experience, to put together an AI product. This is just a part of the products that our business units pursue. TagMe, that will be announced. It used to be an internally used tagging platform. Sber site, that's a computer vision algorithm for mobile phones, where you can recognize certain objects in a video feed or in a picture. Graphs, creative AI, generation of music, creativity streak, and there are other projects. I'm not going to enumerate all of those. That's just a part of the projects that have been born. That's just about the experimentation areas that we have been pursuing. Healthcare should be mentioned separately. The AI lab is developing medical imagery analysis in a great fashion. Cancer detection. We have recently implemented this solution to analyze CT scans for COVID-affected lungs. I'm not going to really waste the time. I just hope that today you're going to hear about some projects that the ecosystem has been implementing. Those are going to be very interesting speakers going forward. I truly hope that you will enjoy these presentations. Enjoy the viewing. I'm going to try to moderate and not let the speakers get carried away. You will have the ability to ask the questions. I'm going to put those questions to the speakers at the end of their talks. I will try to stick to the timing, to the schedule. So perhaps I'm going to wrap up my intro and give the floor to the first speaker, Dmitry Markov, General Director of Vision Lab. He is going to tell you interesting things about computer vision implemented in Sber, about the very interesting implementations in the products and services. Vision Labs hardly needs an introduction. That's one of the coolest companies, not just in Russia, but in the world as well. As far as I can tell, they recently scored very high in the international rankings imagery recognition. So, Dmitry, you have the floor. You've got 25 minutes together with the questions for the talk and the questions, so please stick to the timing. Computer vision in the ecosystem, products and solutions. Andrei, dear friends, dear colleagues, good afternoon. I'm really glad to be with you today. It is a great honor for our company to participate in this important event dedicated to AI, the AI journey, and we are really happy to participate along many other leading Russian and international companies. My presentation today will cover our solutions and products that deploys computer vision technology. Structurally, it's going to be three parts in the talk. I'll tell you about our company and the ecosystem of our program solutions. And I'm going to tell you about certain projects already implemented. And finally, I'm going to share some of our plans for 2021, because we are at this conference, AI Journey. We will try to tell you about the new technologies that we intend to take to the market in 2021. Our company has turned 8 this year. We are a resident of Skolkovo. Today, our company is about 160 people strong. Most of them are scientists, developers, and engineers. Apropos, we are very proud of our team because some of the scientists on our staff are well known in their communities, both in Russia and internationally. I'm often asked about how we survived this year. On the whole, I can say that we are pretty glad about how we progressed. Not only were we able to maintain our team, we actually expanded our team at the outset of the year. Between January and October, we actually hired 50 people, but also we expanded geographically. At the outset of the year, we only worked in the Netherlands and Russia, but until the end of the year, we are going to open a representation in Singapore and Dubai, and we will probably have enough time to open a representation in North America. The most important projects that we have look like this. Our solutions are used in the wondrous city of Singapore. Our solutions are used in Charles de Gaulle Airport in France, in the office of NVIDIA, the police of Dubai, and Emirates NVIDIA Bank. We also have a very interesting project. Our solution is used in the Olympic stadia in Japan. One of our main achievements over the previous years is that we are in the top 3 of algorithms according to NICE. This is one of the most respected competitions, and it's very important for us to come up high in those competitions. That's one of the quality KPIs, and we only have this one KPI. Very often we get asked the question, why do we need this? Because being number 3 or number 5 or number 10, that's not really important. We think that this is not right. We think that this is important. This does affect the recognition of the company, because if you come up number 3, or if you come up number 1 in certain areas, that allows us to get in touch with pretty much any company in Russia and abroad. And we also see that some tenders, especially in the Middle East, they say that the participant must be in the top 10. That's why it is important for us to be aiming. Yeah, if we speak about the ecosystem of our projects, then it looks like this. We've got 3 main components. Flower, that's our own framework that we developed ourselves. We are not selling it to the market, but we are developing all our solutions based on this framework. We've got an SDK, that's a toolkit, including the various libraries for face recognition. It can be introduced into mobile devices and into server applications. That's very popular with coders of various solutions. And we've got a Luna platform. That's a fully fledged solution that is used by end customers. Right now, we are maintaining an absolute majority of the operating systems in the market. Our mobile SDK works on iOS, Android, and next year it's going to be supporting Aurora. Our server SDK is supporting Windows and the various versions of Linux, Red Hat, Ubuntu, etc. We work with the most server types. We can work with the main processors, CPUs, and we can work with graphic processors. Our strategy is to have the best and the quickest math that is capable of working on absolute majority of platforms. That said, our math must require the least resources, and this is the parameter where we must be ahead of our main competition. This is only necessary for one thing. Regardless of whatever segment you introduce your solutions into, computer vision solutions into, those solutions could use our math. That makes it much simpler for us to use in various countries across the world, not just Russia, because we don't like to write interfaces very well. We are writing one of the best maths that we think in the world. Now, applications. I put together this slide to give you a set of examples from the financial sector. For instance, using Sberbank's example, what are the standards biometric technologies used in the world, in the market? Mostly we see biometric technologies resolving 2 tasks. They improve the comfort and the convenience of customer using various services, and they bring down the fraud incidence. Now, simply put, the architecture of all the biometric systems is pretty much the same. There are biometric platforms implemented in the infrastructure of the customer that stores the templates. And you can verify the users, you can log the users in the database. The information is fed from the various devices for that database. ATM cameras, stationary cameras. In the upshot, what the user gets is this. The system identifies and verifies the customers across the service channels. ATM machines, mobile applications, bank branches, web services of the partners. For instance, one of the cases that's very common, it's also used by Sberbank, that's the ability to confirm your identity without having to call the call center. You can just look into the camera of your smartphone. That confirmation is generally required when the fraud management system suspends a transaction, for instance, increase of a daily exposure amount or a transfer of a very large fund, of a very large amount of money to a certain person. Another use of the biometric technology is ATM serving customers without the use of a card. Customer approaches an ATM, and the customer chooses biometric authentication, and after keying in the additional PIN, the customer gains access to his account where he can transact whatever he needs, withdraw cash, make a transfer, make a payment. You have to say that this functionality is available not just in ATMs of a premium kind. In Sber, this functionality is available in over 10,000 ATMs. And this is a good example of improving customer service quality, because if a person forgot a plastic card, if a person forgot the passport, but he does need to withdraw a certain amount of money in cash, that can be done without documents, that can be done without a plastic card. The same way, other biometric systems operate in the same way. For instance, in smart cities, biometric technologies are serving criminal search systems. There are different scenarios, of course. There, the stress is on working with black and white lists. Access control systems, offices, stadiums, transportation hubs, you can not just allow people to enter, you can also control. For instance, you can control the temperature of every person. Heat sensors are deployed here. In retail, it is increasingly important to ensure the customer ability to pay using their face for identification, and they need to put together black and white lists to catch criminals that are professionally employed in stealing goods from shops. In retail, it is as important to manage employee time. When people come, a timestamp is made. When they leave, a timestamp is made.
Our company, around 18 months ago, started to develop our own range of devices. At the end of the year, by the end of the year, we have developed quite a lot of terminals, and we have delivered them to Russia. That is on the slide. In the first row, Luna Ace, the portable access control terminal. Its main features is that it's using Linux operating system, which is different from the similar products that use Android. It helps to ensure very high standards in cybersecurity. This terminal was certified by Bison company, a cybersecurity company. It has a very high level of cybersecurity, and it is used on quite a lot of facilities. Another terminal that we have delivered in Russia in big quantities is Luna POS. It's for payment. It is not expensive, yet at the same time has a high level of protection from various levels, from various types of attacks. Heat terminal, heat detection terminal. We don't do and produce the thermal cameras ourselves, but we integrate it with our devices because we want our customers to manage single system, one system. This year, we're also going to continue our effort in developing and manufacturing new services. Lunar Ace Mini is a small Lunar Ace. It's much cheaper, has no screen. We have developed the second gen of Lunar POS. First of all, it's going to be cheaper than the first version. And secondly, you'll be able to work with cards and non-contactless payments. Have to note that the major competitive advantage that we see is that all our terminals are managed by a common management control system that helps the setting, the fine-tuning and maintaining of these terminals much easier, especially when they're located in various places. The creation of the special video camera that registers the environment, and we developed it specifically for cash collectors of Sberbank. We hope that we will produce several thousands of those. These devices are used in many companies and many facilities. It's used in Sber, in a VTB bank, in MTS. They were delivered to McDonald's restaurants and to several schools. Lunar POS is now used in Prime, McDonald's, Magnet, a grocery store, and Papa John's. I'd like to say a few words about our computer vision when our solutions are imported on other devices. In February this year, we were suggested to use our computer vision developments in the product that has been recently announced by Sber. It's called Sber Portal. It was quite a challenging project for various reasons. All algorithms that we had to implement on the device had to work on-prem without sending data to the cloud, and had to work 4K 25 frames per second. Back then, when we made a decision to participate in the project, we had absolutely no data to train these algorithms. At the same time, the false positive problem was a pertinent one because they directly impacted the customer experience. Another difficulty that we saw is that you had to work not only with static but with the dynamic gestures, which complicated the challenge even more and did it significantly. We were able to develop the algorithms. We were able to implement them on this device within the time frame set by Sber. Basically, it has become a new stream of our work, working with vendors of equipment to pre-install our solutions on their devices directly. The same team that worked on importing our solution to Sber Portal is working on the similar project, but with Huawei company. We import our video analytics algorithms on their new solution that they announced this year, which is called Atlas. It's important for us because our clients, the clients, when they're going to get Huawei solution, it will have Vision Labs installed already. A few words about our plans for 2021. For 2021, we have a number of strategic tasks. First, recently, we have developed a new version of our platform. That is the 5th version, and it helps to work with the huge amounts and volumes of databases, and it can do it quickly because those who have Lunar 4 version asked us to increase the speed because the biometry is becoming increasingly popular among people. Currently, the load is around 150, 200 requests per second, queries per second. We expect that in Luna 5, we will be able to increase this 2-3-fold. Next year, we will also try to launch 2 other products. The first product is called Luna. It's a tech. This is a product that helps to identify people by their silhouette, the details of their garments. And we have several possibilities of using it. And the second product that has already been done, it's called Luna OCR product. It helps to automate the transfer of the information from a picture from a mobile app to some information systems. Now, how does it work? It works very simply. A user that wants to register in the information system of some service or a bank had to go to the branch or drive there and wait for a long time when the bank tellers, bank employees had to retype their data and enter them in the systems. Currently, you don't need to do that. You just need to have an app. You take a picture of the passport, of your ID document. You take a picture of yourself. The system compares the photo on the ID and your selfie photo, and it will automatically transfer all the ID data. It will validate the passport, and the customer, therefore, can become a customer of a bank without going to the physical branch. The showcase is a portal of self-employed in this federal tax service. It's very simple. You download the app, you take a picture of your ID, take a selfie, and then you become self-employed in some time. Another technology I would like to talk about is the technology that helps to monitor the movements of people using CCTV cameras. We call this Luna ATAC. The underlying principle is simple. This is similar with the face recognition system, except for the no factors. In face recognition systems, a person is identified with the face. Now you can identify a person with using hairstyle, body, clothes, and some other parameters. This year, we have piloted this technology with one of the retailers, and we wanted to understand whether it is applicable in real life, and do retail customers need these technologies? Retail shops, I mean. We took a grocery store located near our office. We installed 12. There were 12 CCTV cameras installed. There were no special cameras with face recognition features. These are the quite an outdated CCTV cameras that were installed there. The owner of the shop also provided us with a map of the premises. We calibrated these cameras and we fine-tuned the algorithms so that you can find a person in terms of where they are, using the silhouette and map them and see them on the map. And we will tell you how the technology works. So at the first level we detect a person. On the second level we use the video to create the kind of a stream of stream of photos and videos of this person. And then there is a matching with other people that went to the store, and then everything is then put on the map. Many people ask, why do you need matching? The re-ID technology, as it is called, identifies a person not using one camera but several, because some cameras might not see this person. Because, for instance, if this person is standing beside uh, some pillar, this is why we needed this re-identification. We had a heat map that we got, as you can see on the slide, and our results satisfied the client. Now we think about how to integrate this data in the information systems. So the time is up for me. Thank you very much for your attention. I will be happy to answer your questions.
Да, Дмитрий, спасибо большое.
Dmitry, thank you so much for your presentation. That's true, you have a great experience in research related to computer vision, but what is the most valuable is the pragmatic applications. So we do wish your company a great development outlook, and this is the example of how our talented guys can conquer the world. Thank you so much for your presentation. It is my great pleasure to introduce the next speaker, Dmitry Derimovsky, the Director General of the CMT. It's a known company that is working with NLP and speech recognition. Dmitry is going to walk you through the real cases when their solutions help to change the business and the business models, and how do they improve the efficiency of companies. So, Dmitry, you have the floor. Please make sure you go within the timing. Interpreters cannot hear the speaker. Yes. So we're going to talk about the real AI cases and how they transform everything. So it's very important for us to view AI not as just technology, but to look at it through the perspective of business opportunities. And Gartner said that by 2023, at least 75% of the organizations will not only pilot, but will implement AI in the practical cases. Technologies are changing. What used to be very complicated and available to a very thin layer of the society is now popular. AutoML, automated machine learning, and other technologies help to use these technologies in a very simple manner. AutoML, the best thing there is the automation of machine learning. And that means that all these data and data science becomes available to business users, not only to data scientists who have special skills. That means that people can spend more time on resolving complicated business tasks, and the implementation of AI for business means the manifold reduction of time to market. This really drives the importance of data that are used for ML, for adaptation of algorithms. The corporate data are very important. Their quality is paramount because how they will reflect the state of the business in the current moment is depends on the quality of this data, and now many companies, for them, it is on top of the agenda. In a nutshell, there are three key business needs that AI can support: the automation of the corporate business processes, working with customers and employees, and getting insights using data analysis. And I think that in all these three areas, you can say that, without exaggeration, that now products are being created that resolve real business cases. And today I'm going to share with you the most interesting business cases. I will show you which results we were able to achieve with the companies that implement our technologies. We're not going to talk about the healthcare today, because as part of the conference we will have a separate session, although in Moscow there were some very good showcases of voice recognition in the healthcare. It helped to save 25% of time to analyze the medical scans, computer scans, and other types of scans, and like MRI. But anyway, if you talk about working with customers and employees, it's very hard to imagine a smart contact center without smart assistants and robots. They used to be something that is not needed, something that is not required. However, during the pandemic, in e-com, in telecom, and in other industries, the load on the call centers increased dramatically, and that means that it was not very hard to forecast. So the use of AI became just the thing that you have to use. The bots and voice bots helped greatly the healthcare system and the entire country, because there were many calls from the citizens. At the same time, moreover, it's used for working with not only with customers but with the employees, because companies try to streamline the communications within the company. They take these robots take different tasks on answering calls, emails. There are a lot of cases of using smart assistants. Some of them in insurance. These are the cases when the requirements are being processed and approved. The information on the status is given. In healthcare, the appointment of a doctor that will come to your place, appointments at the hospital, removal of appointments, other notifications, and the invitation to do full checkup. Many other cases in utilities, a lot of that is used too. The meter indicators, the information about the fact that the supply will be switched off in retail, finance, and telecom. Soft collection, providing some information needed by the customers. As for Tele2, that's a mobile carrier, we implemented a telebot in the customer service center. So currently, this chatbot that has been implemented is one of the most popular channels. Every day, it processes more than 15,000 requests. More than 1,000 questions can be answered by this robot. That's led to the fact that around almost 80% of all requests are being processed by a robot, and the rest is upscaled and to the operators. So the operators get some escalated cases that are quite complicated. This saves times and obviously improves the loyalty of the customers. Now, one of the last cases, basically today we announced this news that in November this year, together with Sberbank and with Moscow Metro team, we implemented a chatbot for passengers, and it has been commissioned 2 weeks ago. The virtual assistant shows almost 90% of automation. So it answers 88% of the requests without escalating to the operator. We had around 75% as the target, but during the first 2 weeks when it was commissioned, we moved to 94% of requests processed. The most popular topics was the fee policy, the payment methods, the services provided by the metro, and the discounts, the social discounts. So basically, these are the questions that are mostly asked to any organization, especially such organizations as Moscow Metro Station. Now, the analysis and insight. There are some solutions that understand the context, not only some problematic. We can resolve, basically they can resolve any question. And it does not only controls the quality of service, but we can also find what are the areas, what are the streams for investments. And you know this term, hear out your customer. So this is used for that exactly. So we're not only talking about contact center or chat or some online platform. We're also talking about point of sales. Today recently we have developed and launched a solution together with Avatar company to understand what is happening in POS when the Avatar cash registers are used. So I had microphones. We have these microphones, and they help to form this new layer. And everything that was happening in the service channel, you know, with contact center, it was easy. Obviously, the sheer size of this information, it was not able to analyze all that. Only 5-7% of information is analyzed, but with voice recognition, you could analyze 100% of the incoming calls. And this is really good to analyze what happens when you interact with the customer. We have been implementing these solutions for a number of years, and we understand its efficiency. In terms of offline, talking about point of sale or brick-and-mortar shop or car dealership or some document registration authority, people communicate all the time, but it was a black box because the owners, the management could not understand what happened within this team. So there was some interaction. There's a CRM. The sales go down or up, but you don't quite understand what drives that. Now this task can be resolved, and we see the real outcomes that these solutions deliver. In the research about the quality of customer service, global research, LTD entity company delivers the following data. The voice of the customer gets more outcome. 65% say that the loyalty of the customers increase. More than 50% increase their income, and up to 40% of organizations cut their costs when they use these solutions for analytics. An interesting case for us with Kazakhstan, a Forte Bank, one of the largest banks of Kazakhstan. So the management was asked, this Kazakh, Russian and mixed Russian and Kazakh languages are being recognized in this bank. So the metrics were very interesting. We increased the number of analyzed instances from 7 to 100%. We decreased the number of recurrent queries by 20% almost. And what is very important for any contact center is about forecast quoting is that we decreased the average service time by 13%. The pandemic obviously influenced the digital activity of the population. Now we see the digital me movement, so to speak, digital me trend, but we have to pass through authentication and identification procedures in a timely manner. Biometry is used for that more and more often. You can in the future buy groceries with your with face recognition, go through the airport controls and so on and so forth. The same biometric data was used first of all for security and comfort, but right now we can see that these biometric solutions are used to minimize the contacts, which is very important in our times. If you look at voice biometric, we look at the voice channels that we analyze in the phones. We worked with Prior Bank in a Belarusian bank. We have launched this product quite a long time ago. Apart from understandable outcomes of fighting with fraud, our colleagues and partners helped to significantly decrease the time needed for identifying a customer, and they started to use this time for additional sales, like cross sales. It obviously greatly improved the finance metrics. So instead of just being a unit of a company, a contact center became a totally different unit using a totally different model. Another interesting stats from our colleagues from HSBC Bank. In 2019, our colleagues calculated the blocked fraudulent attempts that used voice and telephone channels, and they confirm that, well, almost 500 million US dollars was saved thanks to these technologies. Now, any biometry has its peculiarities, and now with the face and voice copying technologies, it's very important to ensure there's no spoofing. You cannot use biometry without the protection measures. So obviously you have to focus on that. At the same time, these are the solutions that help to save time and to cut the fraud.
And perhaps summing up, we have to say that systematic reorganization of all the work processes in an organization and implementation of these products is primarily necessary for the people and machines to develop each other and to compensate for the weaknesses. You can't really listen to millions of hours of conversations using human workforce. Cognitive AI, that obviously does those things quicker, but the combination of AI and the strong suits of humans, those combinations really resolve many objectives much more effectively. Obviously, there will be certain pitfalls and flaws on the road, but with the right development of cognitive technologies and products based on them, we're going to be able to take productivity and customer satisfaction to a whole new level. And we will certainly be willing to rejoice on the successes of AI and humans taken together. Thank you very much. So much for my talk. I can take questions now. Yeah, thank you very much. The example of your company is a success story where tech solutions, a tech business really finds custom, not just in Russia, but also abroad. I'm just going to ask one question because we don't have much time left. Now, on the strategy of development, what is your take on the strategy of development of speech analytics, speech recognition technologies? How much can the market change? How much can they affect? How much can those developments affect technologies like yours? Well, we certainly thought about this. Appreciably, the development of technologies, the synthesis and biometrics I mean, we gave the figures, 70%, 80%, 88%. Obviously, the more technology develops, NLP technology, for instance, about 90, maybe 95% of customer interactions will be taken on by AI and various robots, and that figure is always going to be increasing. And today, like a lot of other companies, we build platforms where businesses just forget about customer service, starting from the call center, analytics, robots, through endpoints. All this is sold as a product. In our case, this is Sber Cloud, and businesses can put up the entire interaction stack in just a couple of days, if not hours. Obviously, the workplace is going to be digitized increasingly, and the pandemic has shown that digital workplaces where your communications are around the corporate messenger, you can keep minutes, you can make meetings, and all the things are highlighted, all the reminders pop up probably. So we are working on these two trends, and they will change the workplace dramatically. Us as a vendor and our interactions with the businesses and our daily operations as, a company that employs employees. Thank you very much for an exhaustive answer. I've also got another question. Since this is a science day, a lot of companies are speaking with presentations of their applications. But in your case, without the right R&D, you can't really develop the necessary technology at the right speed. Can you give a few examples of how you approach R&D? You can pursue this activity in very different ways. The previous speakers said that it's important to be part of various competitions because you can't really participate in tenders unless you are a top 10, unless you scored top 10 in the competition. So that requires you to be always on the edge. How many people have you got in R&D? Is it all fundamental or is it all applied research? Yeah, I'm going to tell you, it's a very diverse topic, starting from selecting the team. We've got about 100 people, and this is a pretty diversified team of researchers. We are doing speech recognition, speech synthesis, biometrics, voice biometrics, face biometrics, cleaning out noise. We've got our own chair in IDMO in St. Petersburg, postdoctorals, master students. Our students, our scientists are participating in conferences because it's very important not to be locked in. Any scientific conference is a double-edged sword. On the one hand, you are sharing, and people can steal, but on the other hand, you just can't develop unless you socialize and pick up someone else's approaches. This year, I have to agree with Dima. This year we won in China. That was a world competition in recognizing speech in a complicated acoustic environment. And what really helped us was that we used the biometric element in our stack. And for the first time, we used the voice biometric and everything else. And we were pretty much head and shoulders above our competition because we were able to recognize speech among a lot of noise. So this is very important to be on the edge of all those competitions because they keep motivating you to search for new things. It's very important to be involved in the world scientific environment because without understanding where the world is going, you can't really develop anything of note for yourself. But again, this is a plus and a minus. If you take face recognition, for instance, there's a top rank, and Dima is right that in saying that that does affect sales, but the difference between number 1 and number 20 is fractions of 1%. As for the product differentiation, this is not really mattering. This is not really does not really matter. So you can be a top 10, and this will not be different. But as for the status, as for this psychological, selling points, that is very useful. And this is not exactly the participation. This is the aftermath, the workshop, the aftermath of the conferences. Those hold a lot of values for the scientists. So yes, this is complicated work. We are trying to keep the bar high. That is important for any scientist. Thank you, Dima. It looks like we're running out of time. There is a lot of questions, but perhaps we're going to be able to answer them offline. So thank you. Thank you. Yes, best of luck. And hopefully you take over the world of speech analytics, and who knows what discoveries you might make. We are very happy that we can work with you. And thank you for taking part in this conference. I think you have more than one talk. Yes, we actually do more scientific talks because I represent the business and the company. Yes, thank you, Andrei. That's a great conference. Thank you very much for the invitation. I truly hope that colleagues found this talk useful. And again, have a good day and have a good conference. It's good. It was good to hear, Dima, and I'm pleased to introduce Roman Tikhonov, the director of the validation division, senior managing director in Sberbank, a very important division, very important business unit in the bank. And everything I told you about the data scientists that build models, practice shows that what data scientists come up with should be monitored. And what Roman does in the validation effort, all the models of Sberbank must be cleared by the validation division. All the models must be cleared for release to manufacturing. And there was a lot of fighting, actually, around the models that failed to clear this procedure, and no love or money could push those models all the way to manufacturing, and data scientists simply had to go back to work. Roman is going to tell us about a very cool platform that has been developed by the bank, by Sber, for several years now. It is called Sber DS. That is essentially an example of not having to write the code to create the model. I'm not going to steal the show from Roman. I am giving you the floor now. Roman, please keep an eye on the timing. It's my big request. Hi everyone, my name is Roman Tikhonov, and today I'm going to tell you about managing the models of machine learning on Sber platform. In this talk you'll find out what managing models in big organizations is and how our specific toolkits can help us. History of industrial revolutions tell us that division of labor is the key to boosting efficiency and quality of produce. The same idea underpins the decomposition of managing models' life cycle. We find the people who can do this the best way. We give them the responsibility, we give them the tools, and everyone gets the best performance on their own very own area. Sber DS is this toolkit. We have a standard. The standard says that the life cycle of any model comprises several stages. Preparing data is the first thing. Without that, you're not going to get any model. Then it's development. Then it is independent validation, quality control of the model that we got. We need to validate the model for matching certain minimum requirements or availability of another better alternative. This is a guarantee that we are introducing the best model. So the implementation and the application of the model is accompanied by monitoring. That is about controlling whether the quality of productivity of this model may have improved, may have deteriorated. How does BERDS help us? Well, the first thing is the model library. If you're working in a big organization, then you probably are using several thousands of models. Certainly no one can remember all the information about a given model. There's a lot of properties. And then we appreciate that every model will have not just the specs, the learning code, there's certain artifacts. There's a whole string of other artifacts where there are certain data sets, validation outcomes. That is all part of the dossier. All that information is augmented with the passage of time, and we need to retain all this information. You need to have a library of this. That's a repository of knowledge about the models. Now, the second very important thing is that division of labor is a key to success, as I mentioned. That means that we've got a lot of people with various competencies and various roles. A lot of them take part in managing the models. Data engineers, they prepare the data. Data scientists, they develop the models. Validators, they validate. The implementation team, model owners, they are responsible for implementation and for monitoring. A lot of different people, a lot of different models. You need to manage all this. You need to route. So that's why you need to operationalize this work. No emailing, no file transfer protocols. The document flow, the data exchange, basically you need to automate the workflow. The third point, after we have built up all this work, we need to understand what exactly are we having here. How is the model performing? What are the effects? So we need good managerial reporting. So the library of models is the foundation that underpins the entire model set and all the risks. And then you need to manage the risk of models. If you work in a big organization, obviously, development and application of models, that's not just a sport, that's a tool, a means to the end, and this is improving financial efficiency, better customer experience, etc., etc. And to implement all those advantages, you need to be very careful about managing the quality of models and model risk. Not too much negative fallout is allowed. Performance, reputation, customer satisfaction, these are all the factors to mind very keenly. Let's look at how we can use the automation tools. SberDS is one of the platforms. I'm going to make one proviso. We're not going to prepare the data with you during this talk. That is a topic for a separate, very big discussion. I'm just going to pass over to the stage of development right away. A lot of those present at this virtual conference certainly have the experience in developing those models. Some are amateurs, students, some are professionals. You will know that for development, you are using either a laptop or a pie chart or Arly, relevant environments. That is all well and good with all those environments. But again, you're working in a big organization, and I keep mentioning this keyword. This is a big organization experience, and you're facing brand new challenges. Complexity of the models under development, that is one. And the models have a pretty long lifetime. And based on these models, we might want to prepare something new. You might want to upgrade these models in a swift fashion. And if the model is developed as a Pine code, the developer will certainly understand this code. But if you want to transfer this model to another guy who would need to rework this model, that's going to be a challenge. especially if a lot of time has passed since the model was developed. So Sber DS gives us a visual development tool. If you look at the screenshot, that's a screenshot of a live project in Sber DS. There are certain drag and drop elements. The arrows are the directions of information flows, and types of information, data, specifications, test outcomes, etc. This representation of a development process gives an important advantage. You see the structure of the model. That is essentially a documentation of the model, a visual documentation. It's pretty easy to understand what the components of the model are going to be. Then you can reuse this model. You can give this model to another data scientist to work on. It's going to take one glance at it and understand how it can be adapted to his or her needs. And then the model can be introduced pretty easily. You can train it. I mean, you can show a certain data mart to the model, and pretty much that is it. Nothing has to be done. And you will always be able to control the quality of this outcome. And if you are a genuine data scientist, dyed-in-the-wool data scientist, and you don't recognize anything but a laptop, you can punch in your own code, and you can save your code as a new workflow element, and that is going to save your wisdom for the rest of the bank. And it's not going to be just one laptop that you will generally use. You can use a lot of notebooks. You can, your capabilities of notebook are the only limitation of that. So, as part of a single project, you can write in different languages, and you can use libraries written by someone else in different languages. Those are open-sourced languages. The Python, Arc, Spark are languages where you can just use open-sourced licenses. Why? A lot of libraries are required, and the libraries must be different for different languages. R, Python, they're all different, they're all good in their own right. Also, you can release these nodes, these pieces of code that we reflected on the workflow here. You can launch them in the different IT infrastructures. That gives an advantage of sorts as well. 3 work modes. You can Dockerize in OpenShift. 2, second mode, you can do calculations in Hadoop, and then Spark context. I'm not going to dwell in detail on every mode, pluses or minuses in all of those.
And the last developments is that this platform can create a customized cubes, use a visual built-in kit. You remember, in Visual Basic you had this built-in kit. Just put in the elements and you had an interface. The same is with Sber DS, and you can quickly have a ready model. So we developed a model. You have to validate that. Validate is quite a difficult process to understand the quality of the model, its capacity, quality of ranking, and precision. There are many checks that are included in the validation. In traditional mode, when the model is developed, it's given to validator who gave the opinion. If it's negative, the model is returned to the developer, and using the feedback, it redesigns the model. There might be many iterations. It doesn't happen often, but sometimes it does. That means that we can deliver high quality models, which is good. The time to market, though, goes down. So if those who want to commission the models quickly, they have to use auto-validation. That's another process. That means that together with the developers and of the model, we dive deep into the specifics of the testing process and model. We make functional cubes that were pre-written, pre-developed, and all that is put in the methodology, validation methodology. All that is packed with meta-node in one simple cube. This simple cube is the outcome that is available to the developer. The last cube is connected to the validation node without thinking what is there in the validation. Validator is responsible for that, and then he sees the result instantly. So there are no continuous interaction between the data scientist and the validator. You have the result as soon as possible, and we can move the model from our flow and implement that. So from a very complicated process, we have the same process that is very secure, reliable. At the same time, we have all the other requirements met. Now implementation, that's a real pain after the model is validated, because the processes of the application when the model is developed is different from the systems where it is developed, because they are developed in the lab environments. They have their own syntax and their own programming language, their own sources of data. It takes a lot of time to recode the model from the developing language to the language that is going to be used. We have to understand whether the data marks are used that are right, and whether there are errors and so on and so forth. So basically, here the implementation environment and lab environment are the same. So in just a few minutes, and by a press of the button, the model can be executed. That happens in online mode. It's quick, it's reliable, risk-free, and financially efficient. We implemented the model. Happens next. For instance, we use it for credit process, lending process. A day we review hundreds of thousands of requests for some products, applications for some products. We want our model to be risk-free, error-free. For that, we need monitoring system that helps to control the quality of the work in real time or near real time. Sber DS resolved this issue greatly. At the same time, this is the same problem of creation of evolutionary methodologies. If we make one evolutionary methodology to implement it in the monetary system, we have to push a button called publish and then set the parameters of applying this methodology in line with this or that model. This process is elementary. It looks elementary. At the same time, there's a lot of work done in the background. The monitoring project screen with a lot of tests, all these small cubes, they do very important tasks. They might be 100 elements, might be even more, depending on the complexity of the model. But for us, as for users, it's just one element that is launched and gives the result. If the result is not good, there is an automatic alert for the developers and the validators and other responsible employees that work with the model, and then we can make some actions. For instance, we can decommission the model for a while, quickly improve it, or replace it with a more reliable but less accurate rule. That means two tasks are resolved. First, we manage the model risks. We can manage the depth of the analysis, and at the same time, we improve the flexibility of this control. Think about the fact that you have thousands of models. They have to do tests for all that. Obviously, no organization can have this headcount, so it's easier to automate all that. And by developing one standard project for the monitoring of this type, then you just need to scale. And that means nothing in terms of the effort, because it's very quickly implemented. Why do you need to do monitoring? Because model is not just a sound. I'm not going to talk what is about model risk, how it lives, and so on and so forth. I know that my colleagues will dwell on that. But in the current world, where we bet on using the model to increase the productivity, improve the income, and improve customer loyalty, that means money. And here models become key in our process. So if there is an error in the model, that means it might create some major losses or even bankrupt an organization. You know, like sometimes organizations went bankrupt because some algorithms started to work improperly in some trading. There was some error. There were no limits. There were no control systems and alert systems. All this led to a very bad consequences. That's it, guys. Ready for questions. Thank you for your attention. Thank you so much. I hope you kind of opened up some details on how in Sber your function works. Was I correct to understand that from your report that the data scientist profession will die? Sber DS will do everything, and we will have to find the job, the new job. What will happen? Well, I don't think so. I don't think the profession will die. It will develop. The other question is, what are the functions that would be data scientists responsible for, and validators too? Because, you know, as data science is becoming a tool for financial organizations and banking industry, it starts with some simple approaches with manual labor. At some point of time, we don't need such a headcount with people who can do simple transactions and operations. Models can do that, but people who can develop models, machines, improve the functionality, create new libraries, create new tools, are needed. And they should be scalable for our business process. And for that, you still need people. You need data scientists, you need validators. It's just that their role is going to be a little bit different. So it goes more to research, science, creating some fundamental tools and elements that would resolve some other tasks that might before used to be resolved by some very complicated manual way. So I'm optimistic about that. So right now we shouldn't be very worried, right, as data scientists, and we should not get some new skills, right? I don't think we need to talk about getting new skills and knowledge, getting a new profession, basically. By creating a new model, we should think about our efficiency and the potential of the reuse of what we do. The larger the reuse potential, the more in demand we are as experts and organizations, because it is very important to create a scalable, to be able to learn to create scalable solutions. That's very important. If we wrote a code and it resolves one targeted task, it's okay, but it's not enough for the future. If we have developed a technology, that's totally different. That means that we can implement it, develop new technologies. We can be very financially efficient. This is how I see it today. Okay, Roma, can you tell, like when we talk about the validation function, in recent years, increasingly often we see black box in architectures like deep neural networks. There's a new architecture every week or every month, you know, especially in NLP and computer vision. Well, we understand more or less how to validate and interpret the work and outcomes of some simpler models that are more transparent. How do you address this challenge in terms of the sustainability and transparency of the black box models? The models that are quite complicated when there are multi-layered architectures that are not sustainable. How is it a relevant challenge for you, and what do you think the future holds there for us? Because right now the scientific community is increasingly often asking, like, how do you understand what's within? Why we should trust this? How does it work? because you are responsible for validating all models in Sber. That's a very responsible task, and right now in production, there are increasingly more complicated black box models that are commissioned into production stage. So how do you resolve that? Well, in addressing that, challenge number one is the fact that understanding whether the model is interpretable or not. First of all, our analysis is used by sensitivity testing and stress testing analysis. So we base less on some statistical tests in terms of meeting the minimum requirements. You don't really understand where this threshold of the quality, acceptable quality of the model. We try to understand how the model responds to some external challenges. How is it adequately responding to some a change in external flow, incoming flow, and is it focused on the future? How can it predict the future, and so on and so forth? It's a very important trend that actually will be the most important thing in the industry. Simple alternative, that's the second principle. Sometimes you just need to use some simple alternatives. Sometimes a very complicated model with a very complicated architecture is put to us. We do some simple tests and stress testing, and we try to develop an alternative model using very simple automated frameworks like AutoML and other scalable solutions that we have talked about, which are created by our colleagues, data scientists. And if we see that there is a simpler version of the model that resolves this task with the same quality, or even better, we recommend to use that, because the simpler the model is, the more robust it is. And there's less model risk there, and it's easier to implement them. So simple tasks should not be resolved with complex tools, because they're less reliable. It does not happen all the time, but it is a case. The third, a very important thing to say, and recently it's become more and more popular, is that from pure mathematics and statistics, the model is moved to customer experience. For instance, virtual assistants and chatbots models. It's hard for us to assess the quality of work of this classifier. We want to make sure that this model in real life would not give some unacceptable answers. It is in line with some human ethics. It's not measurable in, you cannot measure it every time with math. And deep diving in the processes that the model is going to be used in is very important. People have to develop scenarios for the model or the pools of models, given the specific nature of its application. Because if it's a chatbot and the customer is talking with the chatbot, the chatbot should not give any unethical, immoral conversations. You understand on the one hand that it is a machine. There might be some error in the algorithm, so it would give some unacceptable answer. But on the development stage, you have to make sure that it is not used in the real life. So here the role of the people is very important. Then auto monitoring. Black box, however we test it, it is understandable that without seeing the structure, without understanding whether it is a robust model or not, we don't quite understand whether it will yield good results. They might go down in productivity very steeply if some external factors are changed. So you have to early diagnose that and use early monitoring tools and do monitoring automatically. That's why we within the bank implement automatic monitoring tools to make sure that these models deliver the results we need. Yes, Roman, thank you so much for such a detailed answer. I have a last question before the next speaker. The function of the validation of models. Is it the story that is specific to the banking area, for instance? There is a central bank that oversees these things and has to validate all that models. And there are IT giants that developed along different models. What are other validation models that exist, and what do you think is the best model, the most efficient model? We have some other examples of models, but without the external expertise, you can't really say that these models work in a sustainable and predictable manner. I would say, I would ask this following question: how is this a relevant story and sustainable story for Sber? It's a hard question. Situation varies depending on the organization or even industry. This is usually confidential information, and it's hard to understand how it is working in some other organizations. The only thing I can say is that validation, if you look at it as a control function, obviously there is some conflict of interest, because to make a model quicker, whatever the quality, and to make the most high quality model, obviously a developer needs to do it as quickly as possible and get the reward. Well, I've been talking in simplistic terms. Validators, in terms of their incentives, have to make sure that there are no low-quality models. This is a direct conflict. If we have these two roles within one person or one team, the results will be even worse. So when the Basel Committee on the banking oversight decided to let the banks use the statistical models, let's call them that way, to understand the needs in capital, one of the major requirements for that was the independent validation function. So it is a standard according to Basel.
In other industries, it's similar. The degree of centralization and the need for it that's all about the price of error, the cost of error. If it's about someone's life, you can't really have centralized validation. And validators should be probably more numerous than the developers. You can see this in aerospace, where models are validated much longer than they are developed, because the price of error is really human life. In some industries, the proportions are different, but you can't really have any conflict of interest. In Sber, we are not really standing still. The auto-validation that the project that we have been embarking on in our platform that I mentioned sideways, the idea behind it is there's no longer going to be a manual process for validation. Someone wrote the methodology, and then the methodology is simply launched into operation. It's just that the developer cannot affect the outcome of assessment. The assessment is done automatically, but the developer sees the assessment right away, and if it is not satisfactory, remedial action is kicking in. So it's a federated model. What happens is the depth of analysis, validatory analysis, kind of falls a little bit, but the time to release to manufacturing, that really improves, and the operating efficiency of the organization improves accordingly. Thank you. We are kind of over the limit, but this is a very important topic, and we are wishing you best of luck in your development. You're everything for us. You are allowing us to, not become unbridled. You are keeping us in check. You are monitoring the purity of models and the platform that you spoke about. I think that holds a lot of potential for the future, not just in Sber. I think it's a great potential for the industry of data science in general. I don't know how official we are in announcing that this platform is going to be available in our cloud, Sber Cloud. It is available, so much as I can tell. Well, it is being tested to a limited number of users, but we certainly have the plans to commercialize it. Yes, so everyone is keenly awaited. The market is probably waiting for it to become available. I think it's going to be popular. Thank you. Thank you, Andre. Yes, and it is my great pleasure to introduce the next speaker, Atari. During the last year, there have been increasingly fewer data scientists in the bank that do not know this name. If you do not know this name, you are not a leading edge data scientist, because Atari is very much at the leading edge of the product in Sber Cloud. That is the cloud infrastructure that was announced a year ago. That's the previous AI Journey. David Rafalovsky announced it at the previous AI Journey conference. And over the intervening 12 months, I think the colleagues achieved a huge progress in deploying the products, and increasingly numerous data scientists in Sber train the models and do all kinds of other things with models. And this is a big step forward for ourselves. And Sber Cloud is available as a product for the external market. Atari is hopefully going to tell us about this, about the toolkit for ML development, and data scientists will probably find it very interesting to hear what exactly we are offering for the market, what the promising tools are, and how you do cool models with it. Atari, please try to limit your talk to 20 minutes, if possible quicker, because we are slipping on time. Yes, very warm welcome, everyone, at this AI Journey conference. My name is Atari. I work in Sber Cloud. I lead the AI and ML in Sber Cloud. My team and myself, we develop the products for the entire cycle of work for data scientists, starting from sorting, assembling the data, and ending with deploying the ready-made services in the cloud. Right now, I suggest we speak about the new methods of ML development. I'm mostly going to be speaking from the viewpoint of the businesses. I'm going to tell you about the traditional methods. I'm going to give you a high-level picture of how you can do the same things in the new fashion. I'm going to tell you about the market of ML platforms, what the players are, and then I'm going to share my own considerations about how you go about doing the interesting things that you can do. Now, our favorite business is extracting all kinds of knowledge from data, building hypotheses, and creating AI services based on that knowledge. Our work is mostly about five elements. Extraction of data, feature engineering, machine learning, reporting, and obviously production deploying. If we talk about the standard method, when the data scientists, no matter who, anyone with the mission to create some kind of a business value with an AI application, now this guy is going to be developing one way or another, and he needs to parse and collect the data. Various tools can be used. Some have to be used. Now, besides selecting the tool to parse certain data from a remote database, if it's several databases, it must be several instruments. And then something must be done with the data. You need to pre-process this data. You need to transform this data. Spark for pre-processing, or Rabbits, or you name it. There's a whole number of tools that you need to work with. Then it is about creating and training models, Python, JupyterBook, whatever. Again, a trillion instruments out there, all kinds of tools. Validation instruments are pretty numerous. The best ones are certainly in Sberbank, in Sber DS, as we have mentioned, to validate a model. You only need to, just move some blocks on the diagram in an understandable interface and predict deploying the ready model in the cloud or inside the company's perimeter, and then you use a ready-made API, so you can use the model. So there's pretty many steps. There's an unlimited number of tools that you need to be a professional in using. Now, here's a vision of how you can create AI application. And this is certainly a full-cycle ML platform. An ML platform of full cycle, that's mostly a cloud tool that allows you to collate data and do everything else all the way to deployment and monitoring of a deployed model in one interface. So if you compare this to a previous method, that really dramatically cuts down the volume of knowledge that a data scientist needs on his way to an end application. So if it used to be, knowing 25 different tools and have 3 people in your team, a data scientist, a data engineer, and to deploy and maintain a virtual machine in the cloud, you also need a system administrator. An ML full-cycle platform, you only need one data scientist to close the entire end-to-end business value for all of your business objectives. So in this situation, the big advantage is exploited by a growing number of ML platforms. Historically, ML platforms arrived around 2012 when Google brought an AI platform to the market. Amazon followed, Microsoft followed. And today, the best solutions in the full cycle of AI application development, that's a startup. H2O.io, famed for its unmatched AutoML, previously unmatched, because our colleagues from the AI lab in Sber really did better, based on benchmark that I saw. They did better than this startup in terms of quality. Now, the main point that I'm trying to make is that startups of yesterday used to ensure better user experience for their users. Now, thanks to this user experience, they are gaining much more popularity than recognized leaders in the cloud market. Those are DataRobot, a leader in SaaS ML platforms with a billion-dollar capitalization. H2O.ai, $400 million market cap. And these companies are about 10. So, going forward, this is a magic quadrant of Gartner. This is a classical mapping of the market situation. In the right upper corner, the recognized leaders, those are, again, cloud IT companies of the world: Amazon, IBM, Microsoft. And we are mostly interested in the lower right quadrant, where visionaries are mapped. That means that these are the heaviest investors in R&D, and they develop new platforms and toolkits that the leaders assume down the line. As you will see, the leaders in the right lower corner, you see H2O.io. We are benchmarking those guys as the trendsetters of the new approaches for ML development. The market saw obvious advantages. That's obviously a shorter time to market of applications. That's obviously cost cutting because you simply need fewer people to develop and use an AI application. You obviously are gaining in managerial reporting because any business who uses a platform, any business can track how the scientists are using the tools. They are trying to limit the access. They are seeing the report, and this really helps your business in a big way. And the most important thing is that the ML platform is spending much more, allows you to spend much more time on research and development. You can create and you can test a lot many more hypotheses. You can cut on the routine things. And here, data scientists are becoming actually more scientists than anyone else. And in this sense, in SberCloud, we are moving in the same direction. We are developing a platform, a full life cycle platform for AI application development. We have already embedded our platform in several businesses in Sber and outside of Sber. And I think we got incredible results. We dramatically cut down the speed of application development in the business, in Sber and outside of Sber. We really cut down the speed of development, the cost of development, and we really expanded the scope of R&D objectives that our R&D team has been pursuing. Pretty much everything I have to say right now. I would like to invite all of you tomorrow at 10 a.m. for the talk by the Chief Technology Officer of Sber, David Rafalovsky. He's going to introduce the new platform of SberCloud, the new toolkits. They're highly relevant for the ML development. Thank you very much. It was great to give you this talk. I'm happy to take the questions now. Atari, thank you very much for this inspiring talk. You finished it with the announcement of tomorrow's presentation. I don't know whether I can ask questions about the things that have not been announced. Well, I'm going to give you as much of a vague answer as I can. Well, everyone is obviously itching to try out the products in SberCloud, the products for data scientists. Now, being as vague as you have to be, what will be the most important feature that will set apart SberCloud from other similar products in the market, products of cloud vendors? Why would data scientists want to go there? I appreciate that David is going to speak at length about this, but I have to put this question to you. Yeah. If we talk about the Russian market, then SberCloud's product is unique for the Russian market, and it is way higher than all the analogs in the Russian market. I mean commercial analogs. If you talk about the international market, our product is going to be competitive, and on pricing, it will be probably superior, even compared to foreign competitors. So I don't think scientists will have to. They will want to use SberCloud products simply because in SberCloud, I mean, we are the developers, and we are probably the laziest developers out there. And this is the way we approach product development. People don't want to spend the time on doing things they have already done 10,000 times. They want to press a button on the routine process and get the magic outcome. Everything happened. You're not spending, 2 hours on the things that you used to spend 2 hours on, and you are doing the same routine in one click. And our products, they are mostly on. They're mostly focusing on giving the data scientists the opportunity to do what they love the most, to research the data, see how they plot on infographics. I mean, that's what that's what data scientists love. And as for model deployment, data parsing, the routine things that data scientists are not interested in, we automated that. Yes, thank you very much. Probably Sber Cloud. I mean, you'll probably say that Sber Cloud made a stride forward over the previous 12 months since inception. And I think you got several accolades already. Did you not? I mean, you were pretty humble in not mentioning that. Yes, we got 3 international awards. The best ML platform in the world, that's us. Well, okay. Don't let's spoil tomorrow's talks. We invite everyone to the talk by David Rafalovsky's presentation. We will be looking forward to that session tomorrow, and hopefully our DS community in Russia and the international data science community is going to be increasingly using this great product.
I can only add that the value here is that the best solutions are going to be deployed there that have been developed in Sber, in the bank, for years for our internal use. So in this sense, in this perspective, there is a difference between this platform and the similar platforms when there are services and products that are created from scratch for external customers, and basically these external customers are testing them. And here, the majority of the solutions were tested within Sber. We have the best data scientists that are very demanding. Yes. I would say hundreds of data scientists with the highest demands in terms and requirements in terms of quality, and we are proudly presenting this solution, and we are proudly presenting it to our most complicated and requiring customer on the market. Yes, so maybe not to push up the advertisements and the. Maybe we should stop here. Well, by the way, about David's presentation, why do you have to listen to it? Apart from a release, the quality of the presentation is absolutely fantastic by David Rafalovsky. He's really good at that. There will be many special offers too, a good opportunity for that, and many free and sexy things that all who listens will be able to get. So make sure you visit David's presentation. Yes, thank you, and I wish all the success to Sber Cloud because, I mean, if you develop on the market, we are all developing and growing on the market. Thank you. Thanks a lot. It is my pleasure to go to the next speaker, Alexei Belkin, the head of the center. I've already talked about the DS function in the bank, how it is working. I said it is a distributed function. We have a chief data scientist of the entire Sber, and we have a chief data scientist of each block. And Alexei is a chief data scientist of finance block. This is basically one of the key business blocks of the bank. It calculates money, basically. What have we earned? What are the risks? That means that Alexei has a lot of responsibility, a lot of important tasks. He is responsible for his entire DS function within his block, and today he's going to talk about one of the cases of ML use for streamlining the accounting. We use DS increasingly more often in some traditional areas and processes. Many of these processes have not been digitized, and Sber has a great potential for digitization and the application of AI. This is why I have opted for working in Sber. You can make models and things that have a very large scale, a very big impact on the activity. Use too much time for the presentation. Now, Alexei, you have the floor. Hello, everyone. It is my pleasure to welcome you to the conference. It would be great to see you all offline, but I hope that you can see me all right and my presentation. I'm going to talk about how we use AI in accounting processes. For AI and finance, in finances, it's very important for there's a great potential for analytics, and for us, the finance guys, we have to improve the efficiency. So we have to start with ourselves, as usual. And we thought, can we use AI to automate the most routine transactions that we have in finance? We looked at the most routine operations, and now I'm going to talk about our success story. The project called Accounting Robot, the automatic checking of the documents to pay for the contracts. This is 2 million documents per year. It checks the banking details, so that's the business commercial contract. We used NLP, computer vision technologies, and other technologies. These models were implemented. 70%, 100% of the models were implemented. 87% of the documents are being checked automatically. This processes look like that. Initiator of the payment has a task to conclude a contract. They conclude the contract manually, enters the information within the system. Then those who do it basically put it in the system. Then when you need to check, by getting the document, you have to enter that into the system manually. Those who do the job basically checks it all again. So quite a lot of manual work, and the worst thing is that you have these documents in front of you that you have to check, and you have to very detailedly check whether everything is fine, because maybe we could for instance, fail to pay for some bill, or pay excessive amount, or break some rule. So it's pretty simple. We have a contract that is concluded on paper. We have the process in the bank that when all the contracts are electronic, but it's still the paper version of the contract is still relevant. So you have a contract on the one side that is on paper, then there are documents to pay for that. Everything that we need to do is to take all the relevant information from the contracts and from the package of the documents, and then reconcile that. So this is what is done, basically. Currently, only the right-hand side is working. The contract is registered and the data are entered manually, but the contract is checked automatically. That means 34 instances, like the banking details, what do we pay for, the purpose of the payment, the amount, and so on and so forth. So 127 business checks are being divided into models. The major part are the neuro models that get the information, 20 for the account, 20 for the act, for the invoice, and so on and so forth. Before you extract them, on this, the document is divided in these four types in these four types. Then we have the NCR model that helps us to recognize the text. After we recognize the text, we have found all the services. We then launch a model that classifies the services using quite a big quite a big material catalog, and then we check the stamps of the partners, counterparties, and so on and so forth. So each model, the model of getting the instances was based on 3,500 marked documents. To mark one document, you spend 1-2 minutes. And we take the platform that we use in the bank for these operations. Now, NeurBERT architecture was built based on the developed and published by Sberbank the architecture to resolve these kind of tasks. It was improved. The transformer libraries were used there too. So basically, you can connect any transformer to that. BERT is now working there. It is quicker and easier. Now, RUBT 3 was published just a few weeks ago, so we cannot really show you the results, but we will do that a bit later on. Then there is a post-processing that uses libraries to filter dates and other things. 97% of accuracy for digital fields and 85% of accuracy for text fields. This is quite a high accuracy, but there's one thing that I have to mention. Stamps and signatures. Now, have to be detected. First, you have to understand whether there is a stamp at all. You should detect the Sberbank stamp, and you should understand that the other stamp is not a Sberbank stamp, and then you need to find a signature. And if it is near the stamp, that means that the signature was made by a counterparty or Sberbank. For that, we needed a data set from 3,000 documents. After augmentation, we added the noises and other things. We improved the quality, selected the optimal amount, and decreased we improved the accuracy by 4-fold, and the error rate went down 3-fold, which is pretty high too. But there was another thing about which I will say later. YOLO V5, 47 million parameters, pre-train on Coco Train 2017. Not going to talk about the details here. It's much quicker. The quality is the same, compared with the previous version. Basically, you know about these two models. And another model that is classifying the services. It is a pretty exciting thing here. We have a description that we had to classify. We used white CNN architecture that was trained based on 35,000 names of services. And this selection, quite a large selection, was delivered by semi-automatic mode. We had the documents that were classified by the accountants, and they categorized these documents already. So basically, we have got the information using the models and then matched both of the sides. The accuracy of the outcome was 22F1. So there is an additional column here, the number of packages that were detected correctly. Now, if for each package you have an accuracy rate of 92, for all services you have a lower accuracy. Now, this is the accuracy figures. When we take an account, we have 96% of accuracy for a separate account. But if we take all the entities, the accuracy goes driven down to 70%. And the same for every document. each model separately is super accurate, but if you take them separately, the accuracy goes down dramatically. Now, what is our current level we have been able to achieve? How do we implement that? We took all the platforms. We took the IDP platform. This is a platform within our bank for processing of the documents. It has an orchestrator that launches ML and Amplifex capture engine that does a PCR. Then we made an orchestration of the models where we recognize the text, as I said before. Then within the text, there is a classifier, and then each document is sent to each model, to relevant model in parallel mode. So what do we have in real life? It is working. The average accuracy in the proper conditions, in clean conditions, when we take a document and when we put it through all the classification and entity filtering and all that things, we see that 96% of the checks are done correctly. So if we take a text that has been marked and we compare it with the marking in real conditions, we take a real documents and compare it with the database, and then the accuracy goes down quite significantly. Why? Because the quality of the scan is relevant. There might be something, one thing is in the system, and we have seen another thing in the scan because it was recognized in a not correct manner by the system because the scan was bad. So this document has to be processed manually then. And then there is a quality to the question of the quality of the data, because it does affect the outcome. Therefore, our goal was to fully automate the routine transactions. Currently, we have significantly automated the entire process and helped to cut the cost significantly. We had 85% of our checks are automated. At the same time, we failed to automate it fully. We are continuing to work in this area. To this end, we are open for cooperation. We find the ways that would help us to move the accuracy of these models to the level of the humans, because humans don't have these problems. With humans, it's 100%. We want to get near this indicator. That's the accuracy rate for the humans, 100%. At the same time, we want to make sure that our achievements and developments are available within the entire ecosystem. We hope we will be able to do so, and all of the companies within the ecosystem will be able to streamline their processes, and hope that it will be available to the market too later. I would like to thank all of the teams, the data science teams, agile teams, and all the other teams for their contribution. And now questions, please. Thank you so much for such a great showcase of implementation of a state-of-the-art model in the traditional processes that everyone understands. Some traditional processes, so to speak. When we implement the models, when we commission them, here you used quite new architectures. What were the challenges in implementing and deploying these architectures? On the one side, you can research some models. You can kind of play with them. The other thing is to commission these models. To what extent it was difficult? What were the lessons learned? And what did you have to go through? Well, I think two moments that we have, if we talk about the implementation, there were two problems. These models are quite heavyweight. In this container infrastructure, we were not able to go through the standard way within the bank. At the same time, so we had to change the infrastructure a little bit, to fine-tune the infrastructure to make sure that these models work. I've heard these questions from other teams too, so this is quite a common situation when we have to work for the IT infrastructure so that it can process very heavyweight models. The second thing is the orchestration of the models, because it is important that I know these models, they require quite a lot of resources, and the documents that we have to make sure that we have the time to process them. This orchestrator appeared not by coincidence. It helped to really speed up the work. And maybe the third thing I wanted to mention, not related to super complex models, you have to make sure that in live conditions, the accuracy of your model might be very much different from the accuracy that was shown on the samples. Because you clean the samples, whatever you do, you still clean the samples, but the real data are different. Thank you. Alexei, how do you plan to achieve this ambitious goal of achieving 100%? How do you plan to have this basically error-free model? This is an open-ended question, really, an open question, you know. It was a kind of a provocation when I talked about the percentage. It is a scientific day we have today, so this is a scientific task that we have to resolve. And it would be good to understand how to get that. But intuitively, I understand that if I launch many models, if each of the model gives higher accuracy, but I use a lot of these models, then I have this good accuracy. And depending on the models, if I have 100 models, my accuracy will go down to like 50%. You know, the overall accuracy. I mean, I can fully process the document, knowing that everything is good there. But should be a different approach that can share the information between different instances of the model. If I compare one model with another model, you know, I want to make sure that, you know, if this is a duplicated information, I don't want to get this from another document. So, you know, you need to use a different approach here, and we're still searching for the ways on how to do that. We don't have the answer yet. There is a feeling that these standard methods that we use to increase the accuracy are not really the best ones. You know, I mean, they kind of improve the accuracy, but it's still an open question. You know, how do you increase the accuracy so that it's really good? To what extent are you linked to a type of a document and restricted by a type of a document? How much time did you need to learn a model? For instance, there is a new type of document that you have never seen before. So this document is totally different from the others. The essence of the document is the same, but it looks totally different. How to make sure that you process the documents with the same quality and accuracy? Well, I would open a small secret. We have only two models. One model for the invoices, another one for the like utilities and the commissioning document. When we added new models to the same model, learning the same model, the accuracy actually improved. When we only started to develop that model, the model was ready only to get the instances from the contracts. And the colleague said to us, it's great that you started with the contract, but we want to start with the invoice. Let's try to put invoice to the model that processes contracts. These are totally different documents, yet the model was able to find the bank details and other things. But this was the model for the contracts, and the invoice is still a different document. So the flexibility is, we have much more flexibility, you know, and we can quickly scale it to use other documents. So yeah, basically, this is how we did it.
Один из главных такой
Well, the main
из главных вопросов с точки зрения
issues right now in terms of training a model
ходу one-shot
is, one-shot learning, few-shot learning.
обучающих примеров,
You need increasingly fewer training sets
архитектура, где что-то предобученное, да, там,
and
для решения новых задач,
something pre-trained being used for resolving
модели трансформеров,
new
или, может, и даже
objectives. All those transformers,
что нам
it would seem that
очень много специфических каких-то типов данных, где
where there are specific data types
и
that you can find
классические модели,
as open source and train classical models,
ваш пример,
such approaches are increasingly more interesting for us. So your example is one of those successful instances. So perhaps one final question, and then we're going to give the floor to the next speaker.
доклад, вот я тебе презентовал, я не
It's going to be a bit less.
спикеры, как я их
Yeah,
расхваливаю и презентую, к сожалению,
I don't know whether you heard how the speakers get praised by me.
chief data scientist
As the chief data scientist of the finance business block, we're talking about DS&AI in Sber.
я сегодня
In your position,
вопрос с коллегами с ЦРТ,
I put this question to
идет такой
the Speech Technologies Center.
ран,
There's always a trade-off between, run objectives. You need to do certain things for the business. You need to run the business, transparent, understandable, sometimes boring. Things need to be done in building the models, with clearly tangible financial outcome. On the other hand, you always want to try something new, and it's always an experiment that you are trying to save more time for. Something that will not necessarily give a financial benefit. You can provisionally call this R&D. You are mostly about the money. You're the most about the money among all the data scientists in Sber. What is your approach to R&D? How much time do you allow yourself and your team to take new architectures with unknown effects?
эти модели
Who would know that,
фактически, да, придете к успеху. Как много ты позволяешь
if you take the model, it's going to give you a success? How much time do you allow yourself on moonshots and experimentation with new models? Yeah, we do that. Let me take a slightly different viewpoint on this. R&D is not exactly about moonshots. For that, we have the AI lab. The way I see R&D, it's like this. There are business customers. They have already adopted AI. They do that in all kinds of things, in optimization and projections. And then there are certain functions where essentially there are no analysts. So naturally, that function does not grow. In accounting, it's just an accounting robot, so there are no competencies in DS. So what we did was we hired the people who pursue R&D in applying AI in processes. We collect ideas, we come to a certain business unit, and we are trying to understand whether it's going to take off or not. So this is a dedicated team of people who is on this process. That's how we came up with the accounting robot. We talked, we understood that there is potential, and we started testing. And in this testing process, let's try this method, let's try another method. There worked really well as for that, unlike that other method, and we pretty quickly arrived at this. So this is generally the approach, and I think that this, AI R&D as a service, that holds pretty good promise for us. You really can control the costs that you earmark, that you assign on R&D, and you appreciate that your R&D is what you're going to eat tomorrow. That's tomorrow's money. I mean, if we don't spend now, we're not going to earn tomorrow. If we do a prototype today, then we're going to give the confidence to the business people that the financial effect is going to come. It's going to come tomorrow, but it will come. Yeah. Okay, thank you very much for a very interesting talk. If there are any questions offline, I don't think you're going to be difficult to find. I think you're going to be happy to share the experience much more broadly than the experience you shared today. You certainly are on a very broad range of tasks. Thank you. Best of luck in developing AI in the finance business of our organization. Thank you. Yes, and I'm now passing over to the next to present Evgeny Grigoriev, the Executive Director of AI Lab. We have mentioned AI Lab many times today. And the lab was established, I think, 2 years ago, as recently as that. And unlike Alexei, who cannot afford moonshots with unknown potential effect, the AI lab is much better positioned to pursue those moonshots. Yet, as it is part of a business organization, they must come up with solutions that must be applied in the bank. And this is an eternal problem. How do you balance research in units like this with the need to come up with practical applications that will actually be implemented? And in my opinion, the colleagues have been able to resolve this, and I think one model that they implemented recouped many times over all the costs, all the funds expended on establishing this AI lab. So I think this is the balance between searching something promising and sticking to down-to-earth, mundane things. And I would say that Zhenya is leading several projects, successful projects in the bank. The NLP technology introduced into several processes in the bank. He is at the edge of this scientific thought, and I'm going to give him the floor right now. Let's try and stick to the timing. Good afternoon, colleagues. My name is Evgeny Grigoriev, and I represent the AI lab in Sberbank. And I'm going to talk about NLP, the technologies and implementations. And this is a rare case when I'm actually going to be speaking on the topic as per the title of the talk. We're going to speak about how the machine works with unstructured information. It is a well-known fact that computers process something numerical more often. What happens if the data is not structured? If it's a text, it's pictures, or it can be a sound? In this slide, we have this process of transferring a text into something digital, that information the computer can be worked with. The machine obviously cannot hear or read or write. The first idea that you come up with is, I mean, if you want to transfer text to something, just encode everything as the figures match the order of letters in the alphabet. Well, the natural sequence is obviously eternal, and if you put together all the dictionaries in the world and number those, we will still have enough figures. But the problem is that when you add new words to the dictionary, Sbol, Sberbank Online, that's a commonly used abbreviation in Sber. Whenever you add new letters, you're going to have to re-enumerate all the words in your dictionary, which is not good. But this is still not the main problem. And the main problem is that the order of sequence in the dictionary in no way meets the meaning of the words, and we are kind of nearing the lexical proximity of words and semantic proximity of words. And a classical example is the example that sets apart these notions. You know, a hen, a cock, an egg. These two entities are semantically pretty close, but lexically they are very different. They use the different letters. Zolota and Zolushka, you know, cinder and Cinderella and gold, these are different things. You know, lexically they are similar, they are close, but semantically they are different. And another representation that you can use one hot encoding. You can take all of your dictionary and you can leave digits 1 wherever the words follow the order of sequence. You know, mama myla ramu. You can encode mama. Myla 0.0 and Rama, the third word, 0.1.0. And this approach does not really resolve the problem of semantical proximity that we have started to speak about. In the English language, there are words social or public. We all took those courses in school or university, where intersections, whenever they deal with the intersections of vectors or whatnot. So there's a set, and then there are, you know, those digits. If the words are semantically close, the intersection is going to give you an empty set, 0. So people started to think what to do about this, and if de facto, what I spoke about, that was the classics of an algorithm, where you can do those vector representations on a limited set. Just think that you need to run a matrix of interaction. There's about 1 million words in English language, and to look at the interactions of all the words, you need to have a matrix 10 to the power of 6 across to 10 to the power of 6. It's going to be a sparse matrix. Obviously, there's not going to be any interactions between words, but that did not used to be a possibility. That's what I'm trying to say. And in 2015, a Czech postdoctoral, Czelos Miklon, he proposed a new approach with vector representations of words. And he called that word embedding. That's more of a... yeah, embedding is a term to use. The concept, actually there were two concepts. You are either taking the... you're taking the word and you're predicting the environment, or you're trying to use the environment of the word to predict what the word was, the keyword that you're trying to look at. And the main concept, the model is pretty simple in terms of logic. The semantically proximate words will meet often in the same sentence. And if this concept is pretty obvious, that's pretty much on the surface of it, no semantics there, you know, just statistical parameters, certain semantical proximities are there. And a classical example is, you know, I like this example. You know, Paris minus France, we encoded the words as vectors. You know, Paris minus France, that's going to be equal to Rome minus Italy. And right now I would like to run across the main trends, just run you through the main trends. GPT-2, our colleagues from Sber, we trained that. And the link that came out on the 28th of May 2020, I'm giving the link here. The main idea is that you don't want to train the model many times. You want to train it once, and you want to apply it to all the objectives. It used to be GPT and GPT-2. Then what the colleagues did, there were over 175 billion parameters, and the training was with the data that is necessary for us. I mean, in the classical sense, you take a word, you do a renewal of the gradient, and then you update the model. And here it's the concept of few shots. You take a task description, you give it to the model, and you give several examples of inputs, and you look at the outputs, and that's only one training exercise. A very interesting development. The article dates the 1st of January 2020. The main problem here is some words might be missing in the text, or the words are used with typos. And it's a problem to create those vector representations of words. You take an entry level, several transformers, and the perceptron introduces a layer with a very stable embedding. A full cycle, pretty interesting article, do take a look. The next article that I would like to run you through, that's the 7th of February 2020. You know, all the models that are industrially used these days, they are pretty heavy. It's pretty difficult to use them. And even this distilled bird, that is a heavy-to-use model. So what the colleagues came up with was this thought: if you take heavy models and you replace them with easier, simpler-to-use analogs, you know, if you maintain the performance of 98%, you might succeed in improving productivity, 100%. And the article really bounces off the paradox of NTCA. You take something, you replace it with, you replace all the components, and can you call this model bird because you replaced all the elements? Another important article dates to December 2019. That's abstract scenariization. Two approaches here. It can be an extractive approach or it can be an abstractive approach. And from a huge amount of text, you're trying to extract a gist. You can take the same sentences and use them, or you can use something new. You can get the model to suggest something, like run annotations or synapses. And the second approach is trying to describe solutions for this objective. Here I'm listing the types of objectives that we have to deal with in NLP. Last year we introduced, I think, about 7 implementations. We implemented about 7 or 8 things in all of these areas. Recommendation systems with unstructured data, dialogue assistance, projecting time series using some contextual unstructured information. I would like to say a few words on what Sber is these days. Sber is a high-tech company, and our products are used in 18 countries of the world. Sberbank has not been a bank for a long time now. There is DocDoc that is in e-health. There is Sber Mobile that is a LVMO. Sber covers a lot of domains of human life, so that is a lot of processes. Appreciably, we have a lot of employees working in the company, and people always will know how to improve their processes. And for them to exchange the information, we created a crowdsourcing platform. It's called Sber Idea. It's about 150,000 active users that generate ideas to improve certain processes. There are hundreds of thousands of ideas. We are working with the main business requester, the processes department, and we try to work on the processes that got the best ideas. We implemented the solutions already industrially. Now, what we focused on was this. We decided to first off resolve this issue of objective search. Well, first off, you have some sort of a query, and there are all kinds of ideas, and you need, I mean, all the users need to keep their bearings amid all this information flurry. You need to give a relevant search response if people are looking for something. So this is what we resolved. We eliminated duplicates. That's another important objective that we resolved. We helped the platform to eliminate duplicates, but increase the overall variety. Some people get the same ideas, twice or several times in a row, and it doesn't make sense to open up a similar project for the same idea. You can just suggest that the colleague joins the pre-created project. We also rationalize the operations of moderators on the platform. There are certain scores given by moderators. Is this idea going to be accepted? Is that going to be declined? It doesn't make any sense to keep the moderators busy moderating the ideas that either have been implemented or are duplicates. Some ideas are manifestly useful, and we only channel the ideas to moderators if they are sort of 50-50, if they are a boundary. We also resolve the objective of a recommendation system based on user activity. We did a pilot, it was successful. We introduced this to manufacturing.
Yeah, so we have different activities. I'm going to talk about this project in detail a little bit later, but the information search is one of the major things here. I would like to thank one of the units, because the colleagues made a communication across the bank that we are implementing AI across the board. Everyone from that unit was ready to mark these algorithms. 3,000 active users of the platform helped us to create this great marking that helped us to make a good retrieval and ranking. So this is the demo of the project. So you can see it's blurred because we have some data here that cannot be published. So basically you have a search query field, and on the lower side you have the search results. So there were two stages here. We took an algorithm. We assembled with the help of the assessors and the users of the process this marking, and ranged and ranked this model. So, I mean, your task is to make sure that the most relevant initiatives are on the top side, and on the lower side something that is less relevant. This is how it looks on the implemented. There are ABI tools used there. So you can add some filters on the left, select categories. You can go to the projects and see the detailed information. Next task is to get the expert opinion and forecast that. Moderator works on the platform, and only the complicated topics that are complicated for the model are escalated to moderation, and the moderators make a decision. Do we need to open a project on this or that idea, or the improvement is not needed? So the demo interface that looks like that. So you can see that there are some forecasted status about the idea, and there is an opinion of a moderator about this initiative. The next task that we have worked with together with the client is the recommender system about the user activity on the platform. So you can put likes or dislikes for the ideas as user. So we got a great database. We have more than 700,000 events that were marked by users. So our colleagues put likes or dislikes pertinent to the information. I mean, whether they liked or didn't like the idea. On the screen, you can see the model on the supposed duplicates. This is the demo interface on how the duplication model looked like. It's very important too because it helps to make a proper moderation and make ideas really diverse. We use neural network when you have input, one input of neural network, second input of neural network. And then you have a duplicate for these two different incomes, and then you make this vector representation of these two ideas. The vector representations are done at the classification stage. The graph theory was obviously used here because, for instance, A is a duplicate of B, B is a duplicate of C, and A and C, on the other hand, though they should be duplicates, but it's not marked as such. So we used the assessors who helped us with the market, and we have built a good graph theory with the classification of data. Well, this A, B, B, C pairs can be added because there are some links within the graph that might enrich your database. Obviously, it helped us to save the resources too. Now, the next task is about the recommender system, when you can put likes or dislikes. We did it with Sber interface. Sber is a loyal organization, so unfortunately, we removed the dislikes. After that, it was a problem for us because we removed that type of activity. We had only comments and likes to analyze. This is how the recommender system looks like. This is a kind of a Yandex 10 within Sber scale. This is how it looks in real life with the interface. So you have an idea, information about the idea. So the Department of Processes now has a wide set of tools of working with AI as part of this crowdsourcing platform. Another thing I wanted to talk about is something that we do with our main client from the sales network, sales block, is the end-to-end feedback. We implement AI methods for the feedback. In Sber, we have a lot of automated system. The process, for instance, what is the feedback for this or that process? Feedback is one of the major elements to improve the process and products. So there are automated systems that are not connected to each other at all. The information about with the feedback has to be somehow processed. For that, we make the improvement, an additional feature with all the systems to collect and process all the information. So more than 16 sources have been connected, a lot of queries and requests. You can see it on the diagram. But what a task we had to resolve? The cross-platform possibility of looking at the queries and requests, because the request might go to various platforms. And so we created an automated system within the end-to-end feedback system. So every algorithm has to be tested for the automated system. And we made a deduplication algorithm. It's a cross-platform algorithm because it is used for various systems, and the quality is pretty good. So this is how it looked like in the demo interface when the colleagues from the sales network helped to make some marking. So we took some click stream the colleagues were writing search queries and put relevant information there, so that for each automated system we would make our own ranking algorithm. This is how it looks like in real life. I would like to thank Ivan Finge, by the way. This is the head of the gamification lab that helped us with the resources to create the UI interface. On the right upper corner, we see the block, the section with the file with the filtration of the data that we want to find, the search field, and some other additional tools that you can connect to the platform, like some stats and other things. Another thing that basically influenced all the processes within Sber is the automatic routing of queries. For instance, imagine you have unstructured information with the description of the queries, and you have to distribute these queries across the divisions that are responsible to answer them. There is an access, as I said, to different automated systems, and when a user reaches this or that, they create the initiative. For instance, a fraud request might be done. It goes to the colleagues who spend time to find duplicates. If this if this query was put to different systems, so context information. This is what we used here together with the client. We assembled a database. We had only 1 month database with around 80 units at first, and the accuracy of the model was pretty good. Now we are generalizing the queries. Around 800 divisions that are responsible for products and processes, and these unstructured text queries have to be distributed to them. We have delivered our algorithm to the clients, so they're working with it now. So what helped us to resolve this task? We were pretty good at working with the database. So we focused on artifacts too, artifacts that we found there. We talked about the embedding of the text. Now we can generalize this structure. We can make vector representations not only of the text, although this is the main thing that we have to route, but we have to make vector representation of you as an employee when you make a query, or we make a vector representation of the division that you work in. That basically put this task, very likely did so. So all that helped to increase the speed of the processes within the bank and save the IT resources. Sometimes one division was snowed under the queries, so it was redistributed. And the embeddings that we put, we made a coordination between these 3 types of embedding. And based on this story, we got the models that showed good quality. Another thing. Yeah, colleagues, you have the sound on. Right, on the next slide, focused on our long-term plans, short-term plans too, the automatic routing of the messages, when all the messages and all the queries are automatically distributed across the divisions. So we will find the divisions with the similar functionality when the colleagues from one department can support the colleagues from another department. For instance, there might be some overload. One department might be overloaded. So we are resolving that. We can also forecast the load on the unit. We use context, not structured text information for that. So you have 2 automated systems. You know that they are united, and there is a quick spike in the number of queries because obviously there are some bugs. By using this context information that these 2 systems were united, that means that it needs more resources and it can improve the quality of the models. As I said before, we also want to automatically redistribute with RAR. So when we will have the forecasted load of the supporting units, the systems will redistribute all the queries depending on the situation. And obviously, creation of the library of the analysis of unstructured data, that's another thing in the plan. Now, to summarize, just a few words about what we need for successful integration of your results. In our lab, there are various clients from the business blocks, and they ask, how do you properly implement all that? And with the sales and department and process department, our work with them showed that 90% of success is a properly organized process and work with the databases. By cleaning databases, you don't need to use complex algorithms. Even simple algorithms can give some very good results. It's also understandable that if you build some algorithms like regressing and other or decision trees, the algorithms might be different, distributed, not distributed. You understand that in the industrial loop, you have to make sure that they work. But anyway, if you make a classical model, you can use the processing capacity, compute capacity. If you use neural network, for instance, we try to use advanced algorithms. That means that you need to have server capacity to organize this work, because, well, I mean, you understand, it has to be Visio card, like Tesla, not Tesla, I don't know, whatever the load is. That means additional budget for the unit. The most important thing, of course, is the team. You need to have an engineer who will work with the database. If you have a front end, a back end, there should be some people who would link these systems. You need to have some graphic designer that would make an interface, user-friendly interface. You need to have a team of analysts who would support these solutions, because there's nothing perennial. Any model has its life cycle, and when we give our developments to the clients, there's always some colleagues who are professional who can fine-tune this solution if the situation changes. There should be some metrics on the degradation of the quality of the model. You need to understand how you feed the model with new data. So basically, these are the three pillars for the success in the industrial, in the live counter. Basically, colleagues, this is what I wanted to present to you. Thank you for your attention. If you have any questions.
Жень, спасибо тебе большое за такое подробное
Evgeny, thank you so much for that detailed presentation. I would love to have some questions, but unfortunately, we really don't have time. Quite a lot of information. Maybe a quick question with a quick answer. In terms of NLP trends in the nearest future, in the nearest years, how it will develop? There are transformers now. When will the next big thing be? The next big thing is no secret, it's agile, where we move. In terms of natural language processing, there were some recurrent networks, convoluted networks. Now there are some transformers and auto-coders and more complicated models. I think there will be some large, complicated models that will try to streamline, in terms of the using them in real business applications. These are going to be used. In terms of science, of course, we move to more advanced AI that can be understood as AGI. This AGI, this is our trend. Well, Evgeny, thank you so much. We wish you all the success of implementing the NLP models in Sber. It's very important that you not only drive these technologies, but you have that. We're broadcasting again. So we have a very exciting presentation coming up. I think I've said about that before, that we will, for the first time, actually openly talk about the graphs in Sberbank. Mikhail is one of the supervisors of that in Sber. He works in my team, and he will have an exciting presentation about the graph platform. Obviously, we cannot tell you everything, but Mikhail will tell you, everything he can tell. Broadcast it again. So good evening, if you're in Russia. My name is Mikhail Stepnov. I'd like to thank the moderator for that introduction. The graph platform of Sber, this is something that I supervise, and we go to victory. Okay, let's talk about that, not about myself. Now, how these two things are connected. A person, Linus, is a sinner in Sweden, and Königsberg, the city that used to be called Königsberg. If you know the connection, you are very much advanced in terms of analytics. Now, the first thing, you can understand that, the task on the 7 bridges of Königsberg was the first task that was resolved thanks to graphs. Maybe some of you have heard about that. And who is Linus? I don't think in our country, at least, people know about that. So those who work with graph, they know Nero4G graph base. Neo, that's his nickname. It was named after his name. And now there's Neo4, the basic graph that was put there was the graph of the relations between the musicians with the sinners whose names were Neo. Now, this is a small introduction, so to speak. Those of you who knew about that, let me know. I don't know if we have a feedback form, but anyway, let's go to the more serious things. Now, graphs, well, the graphs of connections is a very relevant topic. We understand more and more that if we can put not only the information about the instance, but about its relations, we can get much better insights and much more precise models for AI and ML. And obviously, everyone wants to use that, and many use it. I think that basically all key companies, all key large companies and national leaders use graphs in this or that manner. Of course, we're talking about the graphs of connections, where that are used for search engines, including Google ones. And obviously, Alibaba and obviously Palantir Technologies are using that. We are not going to deep dive into the history of this company, but this is the most expensive, most valuable, and most secretive startup of Silicon Valley. There's a lot of things to read about it.
We are trying to be leaders and benchmark the leaders, so let me tell you what we have been doing in Sber on graphs. We've got 3 main areas of work. We have the concept of using graph embeddings and graph neural networks to manufacture graph embeddings. We are developing knowledge graphs as one of the main areas, one of the most interesting areas. And we are using the visualization part of our platform, and you may have guessed that as the other market players, we are creating our own major platform to work with the whole thing. Now, going back to visualization, for data scientists, we are giving the opportunity to improve the efficiency. Let me walk you through all these areas: graph embeddings and graph neural nets. two variants here. GNNs are developing probably the most actively in what I have been seeing in ML and AI. New articles come out pretty much every week, and in many areas they show themselves much better than classical neural nets. That's actually one of the pluses of using graphs. They are much more forgiving for the volumes of data than classical models. And one of the industrial applications, interesting applications, Google Maps is now building the routing model, ETA model, based on neural net graphs. And embedded graphs, that's probably one of the most interesting topics in AI and machine learning. That really simplifies life. And graphs, that's pretty straightforward. Simple feature gets all the neighbors of the given node rolled into one. The funniest thing is when graph embeddings in neural nets, that's just that's a bomb. We built embeddings of entities and entrepreneurs based on a huge amount of data, based on a single client relationship graph. That's a huge graph that is replenished pretty much every day with our knowledge about with our knowledge of everything that we know about clients, primarily entities. So we built the embeddings, and we learned how to improve at least 16 classification objectives in the bank. And besides these 16 things, there's a whole number of things where we just take an embedding, we put the model in, and get a better quality outcome. That's really convenient. We got the embeddings using a customized algorithm of graph convolution network. Why everyone loves embeddings so much? You can convolute out of hundreds of features to 42 or 2, and you can cut the power consumption, you can cut the computation time, you can just use one entity. You can append existing models with this one entity, and the dimensions can improve the accuracy of a model. So I highly recommend it that you use these things. This is a very brief presentation for me to give you any more details, but I highly recommend this methodology. Now, the next step in our development, it's not going to be just graph embeddings. It's going to be connecting pretty much everything that we can to graphs. It's going to be one super embedding that, when placed into a model, that's going to give a major boost to accuracy. And then there are dreams. I mean, these are anonymized data, and sometimes we can actually sell it to the market. Not now, but perhaps at some point. And then knowledge graphs. Let me say a few words about what this is and why it's necessary. A knowledge graph is a less structured thing. You don't have a clear definition of what the relation is between the two nodes. You can see this graph on the slide. It is about greater ease of finding dependencies. The classical example, Leonardo da Vinci, born Italy, Italy to the city where he was born. Can't really remember the name, but this helps you answer the question with an answer. These are search requests, obviously, where you can find something based on oblique indicators. For instance, the very first research paper we did the school graduation exam in history. We actually did a good job there, and the main area of research for us here is the automatic knowledge graph assembly. This model, you'll be able to feed the unstructured data here, and basically you have some knowledge. For instance, you take a picture out of Wikipedia, you add certain more pages, and you generate a graph. This is a shot at AGI. I still think that this is the most obvious approach to generating AGI, to achieving AGI, and this is obviously an opportunity to create a single supergraph of companies where all the information in Confluence, in documents, that is one structure, and you can start making all kinds of products on it, augmenting information, generating new knowledge on it, that is based on projections based on existing knowledge. Hopefully next year we're going to be able to show you some products, and maybe we get together at certain conferences, maybe it's even live. And the third block, well, actually AGI, a graph can be an orchestrator of the weak Intel and weak AI engines. It can connect the necessary service. This is not a fully fledged AGI, but this is a still means to get something stronger out of a series of weak AI engines. I don't know how interesting this is going to be. It's still an interesting picture. We are using visualization here. Data scientists like to look at pictures. First, we use this to look for groups of related borrowers. You can actually get fined for extending a loan to related borrowers. You need to identify a group of related borrowers the right way. If a company ABC stopped repaying you, but then the founder of company ABC might found another company, XYZ, and he came for a loan to you again. But I think I'm telling you the next slide. This is this is still a fraud prevention, and the previous one that I gave you was an example of a holding company. You need to understand what a holding company is. Actual holding company, or a purported or a hidden holding company. And I have actually told you about anti-fraud. You need to understand who is related to what and who is actually what when he or she is applying for a loan. Now to do all these great things, we are putting together a graph platform. This is a complex product that we are doing together with our IT business blog. This is not just a software application. This is a programmatic complex. This includes all the things that I have mentioned before in this talk. We have over 50 internal business units that use these services. Yeah, my presentation is bouncing back and forth. Now, we have been developing this platform for a long time now. It is allowing us to compute all kinds of huge graphs that we have in the bank, and the comparison gives us pretty much this. We are not in the lead in the market, but this is still an internal development. It's not a commercial product. We have not been investing in this development as heavily as startups have and the leaders have, but this is our current state. And even in 2021, we expect to overtake some competitors, and in a year or two, we might actually be challenging the leaders of the market. I have the dreams, all right, but perhaps one day all of you will be able to use this service in the same way as now you can use Neo4j. Visualization, data storage, embeddings, graph computing to compute GNM, that sounds wonderful. You don't really want to buy your own GNX. So much I have to say. I tried to accelerate a little bit. Now it's time for questions. Yes, thank you very much. I think we all have a lot of questions on your talk, and this is an intriguing topic for everyone. So I suggest that folks contact you offline. I know that you're going to be happy answering all the questions, and if collaborations emerge out of this, we will only be happier for it. That's a very interesting area, the dynamically developing area, and we have a lot of data here, so I wish you best of luck in developing this graph platform. And we are passing over to the next two speakers, so far as I can tell. These are colleagues from Sber Devices. You may have heard about this business unit in Sber that has been developing smart devices. We announced Salute at SberConf. That's a smart assistant, a smart device as well. And colleagues are going to be telling us, Valery Arkhipov, Leonid Sidnev. They're going to be telling us about the generative chit-chat model, the interesting conversationist. That's more of an R&D development, but you can still create chat models using generative models. Colleagues, please try to stick to the timetable. Hi everyone, my name is Valera, and my colleague Leonid Sidnev and I are going to be telling you about our experiment with generative chit-chat models, how we are making them more interesting, how we are using them in practice, and how we introduced them in our Sber Devices product. Actually, yeah, let's roll. What we're going to tell you today is about the product objective, how chit-chat models are used in Sber Assistants, and we're going to just briefly talk about training the basic language model, about transition to the basic model to the dialogue model, and perhaps the most interesting thing, pre-training, up-training, and all kinds of heuristics that we arrived at during our experimentation. They improve the quality of our models, and we're going to touch upon the metrics that we use to assess quality, and we will certainly give you the funniest examples of generation. So here's a product definition. You may know that recently Sber introduced a family of virtual assistants, Salute. There are 3 characters to this virtual assistant. Every virtual assistant is a unique personality, communicating in own style, and the various chit-chat models are used for that. The models are responsible for maintaining the context of the conversation generally. They're not responding to a specific question. They can just engage in small talk with a person as he goes about his business throughout the day. So the decision was made to maintain the retrieval dialogue model for Sber and Afina. It is based on a whole number of edited cues. It is essentially a retrieving model. And for Joy, a distinct character, We are using a generative model that is giving answers on the fly, and people are going to be able to compare. One might be better, other might be worse.
Now, I'll show you some examples that we used when we fine-tuned our models. Here you can see the key, on the one hand, advantages, on the other hand, disadvantages of this model. Now, on the one hand, it can hold the context really well, so if a user started to talk about politics or poetry or art about that, model understands that topic because it was trained based on a huge amount of data, volumes of data, although they were not marked. They understand what is the context. But you should not, you should not expect hard facts, because it might actually, think up some information. Like you ask, who is Vladimir Lenin? And it will just invent some historical data about that. What are the metrics that we use in Sber devices for the dialogue models? Why do we use metrics? Because dialogue models is an interesting creature. You cannot really measure it. We use perplexion. We use some other metrics, but usually. But here you can't use that because perplexity, it doesn't really reflect the proper work of the model. We have two metrics, SSA. It's kind of a Google meaner. We recommend that metric. It's absolute. We can compare models within each other, and the interpretation of result sometimes is not obvious for it. The growth of 1%. It might not really understand what to do with that later. And the assessment using this methodology needs some crowdsourcing, because those who market have to be very attentive. Now, Facebook had Blender bot. We think it might be used. We're working on that. It should be good because the interpretation of result, when the pairs are compared, might be quite obvious and will give you the visible results. Now, the structure of our generative model, GPT-2, now GPT-3. Everyone knows about these models. GPT-3, that's what we used. This is auto-regression decoder-only model that looks at the context only from left, and token by token it moves to the next step. There is actually a link to a great resource that explains the structure. GPT-2 or GPT-3 architecture is a kind of a parent architecture here. So we learn the basic language model by using big chunks of text, but it can be used to generate long sentences or even paragraphs of text, but you shouldn't expect it to answer on some short question with a short answer, as we usually do in conversation. So we had to change the architecture a little bit, and we decided to use the approach of Transformers Transformers library authors. So they said, what if we take GPT-2 architecture, and what if we add, like here you have a persona, the history of the conversation, and the additional classifier that will select what sentence will continue the next sentence. It does that while it is learning. This architecture, there were many things that happened with that. We only used the concept, but this architecture helps when you have a proper data sets to train our model as part of some short sentences. Now, let's go to some interesting discoveries that we have made. Leonid Sinyov, my colleague, is going to talk about this particular project in more detail. Hello, colleagues. Now I'm going to talk about how we worked with data and launch parameters, so that the model can have a conversation with a human, pretending to be a kind of a real person. We need special data sets that were, similar to what people say when they're talking. So you had to have a large set of topics with examples. There should be, the context should remain the same as the conversation goes by. The answers have to be human-like and interesting and non-trivial. And as for each persona from the set, you need to have a statistical similarity of his answers. Now, Valera has described shortly how we trained the model for the dialogues. These are the kind of a primitive parameters for the training. The pre-training was done on data set that was around 200 gigabytes. And yes, there were two heads for the dialogue LM, 0.5 gigabytes. One head is LM, and the other head NSP that classifies the answers by correct or not correct. Now, the interesting thing here was how to mix losses from these heads. We understood that good parameters mean it's around 2 to 1. When there are two times, the language loss is 2 times more, and as for 1, that's the loss from the head that determines and classifies the answer, whether it is a correct answer or not. The candidate for the second head was selected in an experimental manner from 2 to 7, the number of candidates for NSP. Then we used some, from random, we went to LSTM for negative sampling, for better quality. And to have a more even context of learning and training, we put a limit to 128 tokens. As for the other things, there was this interesting trick that we used. We decided to generate several answers for the model, and then we ranked it by separate models. It helped us to increase the SSA by 10 percentage points. We used different models from separate neural networks and used some other outputs from the second head and the additional heuristics on top of that. Then I would like to give floor back to Valery. He's going to talk about other generation tricks. Yes, Leonid, thank you. One thing that I would like to talk about, it is related to the generation of answers for the dialogue model. It seems that in the academic environment, it has not been researched. Now we use nucleus sampling that is good for GPT-2 and for in English, it used for GPT-3. Using the empirical methods, we selected a set of parameters, the top P. On each step, we filter our tokens, and the temperature, that's the range, high temperature in this case. I mean, the higher the temperature is, the more conditional the model is, the more it will invent for each step of generation. If the temperature is lower, the model will use tokens that are frequently used in the similar texts and will be less surprising. The answers will be less surprising. There is a greedy generation option, and since we implement the assistance in the products of Sber, for us it is interesting to know how the greedy generation will influence the quality of the generated answer. Now, what is the difference between greedy generation and nucleus sampling? The greedy generation, we take the first token, the most probable token. And we select it and don't think about it any further. With Vladimir Lenin, with greedy generation, who is Lenin? The question, who is Lenin? It replies properly. I mean, it does seem like the truth. It doesn't work for all the cases because there are many texts going in parallel. So if you ask a question, a more complicated question, the answer would be worse. Nucleus sampling, I mean, we'll relaunch it several times, we'll get different answers. But even with the first attempt, you can see that the answer is, well, let's say it differs from Wikipedia. It's more kind of a human-like. I mean, the disadvantage of this approach is that this is, it looks like a human thing. On the other hand, it might be something that is not correct. People would be surprised, like, what is that? And then we wanted to show you some other examples of generation. And I would like to note that it's not that difficult to train a language model. In a way that we have trained the language model on a big set of texts, that means huge resources and so on and so forth. But what do you do after that? You need to fine-tune it on the quality data set. The data from hundreds of social media, sometimes the answers and posts and publications are in different registers, and that means that the quality of the answers of the model, the quality in general goes down, and for that you need the post-release fine-tuning of the model and get some additional heuristics on top. For instance, the ranking of some candidates, there should be a different set there. Selection of the generation parameters, selection of the numbers of selection of the parameters, all that might influence the final quality of the model. And this is something that we continue to work on. In the nearest future, of course, we will migrate our models to GPT-3. We will hope that it will help to increase the quality of generation of our models. For now, you should use virtual assistants of Sber, Joy, Athena, and Sber, 3 of them. Everyone is good. Maybe you would use it in chit-chat mode or for anything else. So this is it for our presentation. Thank you for your attention. Ready for the questions. Thank you so much for that great presentation. I think that many were very interested in terms of how do you implement chit-chat models. This is a hot topic right now, and I think that this is one of the most exciting presentation that we had in this section. Could you please tell us, we had a discussion with Sergey Markov about the generative models and implementation of these generative models in the products. You all know the examples, the attempts to launch systems that use generative models that train on users. The worst example was Microsoft, that became a sexist and had many bad attributes in just 24 hours, just one day. There will always be a problem of filtration of this content, unwanted content. How do you look at that? How do you resolve this issue? How do you plan to resolve it? Because if you put all these filters, you know, any filter can be circumvented and dodged, and it's about the expectation of the people, you know, how they go into interact with Joy, because Joy might, you know, just give you some stupid information. How do you work with that? Yes, thank you very much for that question, Andrei. A very good question, a very complicated one, because all neural network models have this problem. When a model says that this picture is a cat, then you change one pixel, it says it's a yacht. That's a problem. For generative models, it's an even more acute problem, especially when we use some data from the social net media. And the Microsoft case is a good testament to that. I don't think we can say that we have fully resolved this issue, but what do we do to minimize that? Our data that we use to additionally train our language model are very high quality. The answers were changed to be used for the training of chit-chat systems, and there are zero bad messages, bad ideas or answers. There are no insults and bad language, just not existent in this data. This is what we talked about. And if you train the model and take the data from social media, the result won't be great. And given the fact that all these assistants are on all the surfaces,
yeah, there's a very interesting area of research. We actually saw one publication here. It's not really in real time. It's mostly offline, doing this training with reinforcement. But we take all the logs of all the dialogues with our system, and we use a special model that classifies sentiment. Well, we often use speech when we talk with a smart assistant, like marker words. Well, you're doing good. You're not really doing good. You have said rubbish. And these marker words we can mark up with a sentiment model. It should be a good quality model, must be said. But then this metadata can be used with special loss function identification. That can be an uptraining material. This is a very interesting area of research. We are moving in this area. We would like to try this sometime soon, because you can't really not use the logs from from the call centers and etc. Yeah, that's an interesting topic. We could talk a lot about this. And it's great that this is one of your first public talks. And so far as I can tell about generative chit-chat models, you know, it's great that you did this in a platform as big as this. And we are wishing best of luck to your assistants, your characters of your virtual assistant. Hopefully they become even smarter with every passing day. And the customer experience, customer journey, this empathy of communication, this attachment to the assistants, that comes from this feeling that you are being understood. This is not a scenario bot. So generative models should be the way to go. That is an area that should develop. Yeah, I had a chance to meet the founders of that interesting startup. So, guys, best of luck. Great talk. Thank you. We will be happy to talk again. Thank you, Andrei. Thank you. Bye. And I'm now presenting, so far as I can tell, the last speaker. The last but not least, obviously. This is Arina Agiyeva. Good afternoon. My name is Arina. My team and I are working on creating a model to automate HR processes. Today we're going to talk about how to lighten the workload of a recruiter, obviously using ML training. When you open a vacancy, we obviously are always keen to find the best candidate. Moreover, we would like to do this as quickly as possible. Otherwise, competition might snatch this ideal candidate. So what stage of this funnel do we rationalize the first? First off, it is the attraction. You need a lot of responses to the vacancy, to the posting. You need to screen, to vet a lot of... Now, to confirm our choice, let us give you some dry statistics. It takes about 60 seconds to vet a response for the vacancy. An IT or DS vacancy can get over 100 responses. So just sorting through takes about an hour or two. Also, a lot of good candidates are cold candidates, and they might actually not respond to your vacancy announcement. Our self-measurements say that looking for relevant candidates takes about another hour or two on the relevant, classified websites. So that takes about 2 hours at least, maybe 3, maybe 4, to find some good resumes for candidates to call. And since resumes are many for a recruiter, and it's only 8 hours job, so calls might not be placed very soon. So the relevance of this ML system is obvious. Now let's talk about the properties that this ML solution must have. Now, a lot of job sites today already have tools implemented that accelerate the choice. There are all kinds of filters, cities, work experience, keyword search. So why is this not sufficient? Say we want a candidate for a position of a CB engineer, and we need a senior person. So a senior person would be at least develop on Python and know the relevant libraries. Now let's run the keyword search. We obviously have a person with experience, considerable experience, so we rank candidates based on work experience. Now let's imagine that a certain Slavic, a guy who wants to change his employer, posted his resume. Okay, the key skills are there, the work experience is 6 years. This candidate is certainly going to be in the top of the search request, but is he a good fit? No, because he is only having 2 years of experience as a data scientist, and he used to be a salesman before that. And Slavic is far from being the only one who changed his development vector. And these guys are going to be in the same search response with senior candidates. But the recruiter is going to vet them off at the very initial stage. And these candidates are going to be pretty numerous in the final response of the search engine. And if you set the work experience to 1 through 3 years, that's going to be a lot of irrelevant candidates to vet. Also, a lot of candidates will certainly be outside the scope of your search. So it's not just about the existence of the relevant skills. It's about understanding what experience is relevant. And you need to assess the potential degree of command in the skills acquired in every position that is listed under work experience. Now, attempts at resolving this objective is about merging all the fields, building a vector representation for the vacancy, and trying to understand how close the text is for the job description. If you do it this way, you're going to assess the command of the skills based on how much text there is in the resume. And this does not really correlate with how much a person spent in this or that position. So to analyze a resume correctly, you need to treat the person as an object with a complicated structure, and you need to analyze every single field separately, and only after that you aggregate the vector representations from the various areas of the resume in light of the work experience. If you look at the vector representations, you introduce the vector of word presence, but then we're going to start penalizing and deprecating candidates for additional skills. Here you see the description of the main competences that the candidate should have, but the employer doesn't say what the outcome of that activity should be and what the skills matching that activity should be. So should the candidate be able to draw nice reports, or should he be able to implement the models in manufacturing? Slavik is not an experienced DS scientist. And another candidate did remember to mention this, but formally he is going to be much farther than Slavik up in the response of the search engine. And we would like to get a system that will pull up the profile of the specialism and answer the simple question, is the vacancy and the work experience from the same specialism? So what we're trying to get is a system that, one, can get an analysis of a large corpus of resumes and vacancies and learn a certain description of specializations. And two, for every block of the resume, this system must predict the distribution of these specializations in this block and aggregate based on the work experience figure. Now, to create this system, we used modeling, and we built a vector representation for every block that's going to represent the distribution of topics, specialisms in this case, and then it's going to be about aggregation in light of the time spent in every position under work experience. If we use this approach, then we're going to be able to assess that a given resume is a 63% match with the sales manager and only a 37% match to a data scientist specialization. But with this approach, we encounter the following problem. We do not appreciate that changing a specialization is easier than changing a professional area. So a person who became a DS out of DevOps is not going to be a match as much as a guy that turned a DS out of a sales manager. Although the first guy had to learn programming from scratch, and he had to understand the main algorithms. So we do not need to teach just distribution of specializations. We need to teach a certain hierarchical distribution of professional areas, specializations, and specialisms. Now, we used this to train a hierarchical multimodal model. The first two areas are responsible for specialisms and professional areas. They were trained with part reinforcement using the data that's available from job websites, the categorization available there. And that incorporated the knowledge about what category a candidate was given by a recruiter. The third set was taught by regularizers without reinforcement. We were trying to simply identify what the relevant specialisms are for every specialization. So for every single block of a resume, we are getting not just one vector, we're getting three vectors. The distribution of professional areas, specializations, and specialisms. Then they are aggregated based on work experience, and then they are compared to the vacancy. Now, the third thing that should be noted when building such systems, the experience that was received sometimes and the experience that was received in the most recent positions are different things. And if we are looking for a data scientist, then the resume, when a person switched out of a sales manager into a data scientist, that's kind of a more suitable candidate than the guy who worked as a data scientist a long time ago. So we need to raise the importance of recent skills and deprecate the importance of more historical skills. And then when you aggregate the vector representations from various areas of the resume, so we used a certain dying out function. This function used the vector out of the recent skills. Yeah, the vectors out of the recent skills are given better weights, and more historical skills are given deprecated weights.
This is how we use these systems. The rules are pretty simple, and this is how we create and rank our candidates. And for senior positions, we have people who have been working in this area for a long time. And to get the junior position for less relevant, for people with less relevant experience, but it might be an advantage. If you have to create a system, you have to have industry-specific knowledge. For instance, you have to implement a model for sales models, and having experience in sales will have an advantage. You can use the system in many areas to rank external candidates, to train your employees, to recommend vacancies for the CVs that were uploaded for referral programs. As for the key skill distribution, well, we learned the mathematical model. As a bonus, we can use it to create an automatic built-in kit for the vacancies. Thank you for your attention. Unfortunately, we don't have a lot of time for a long Q&A session, so I'll just ask a quick question. What is the current status of this model? So you're implementing it, you're piloting it, you've trained it, we have developed it, I've trained it, now it's in the implementation status. We're going to measure the extent to which we sped up the hiring process. We will tell you about that. Yes, it will be great to know about the results, because the most complicated thing here is to measure the effect, because quite a lot of time has to pass, when you can measure it. And as for the quality of people, it's kind of hard to measure that quickly. So it would be good to know about the results. How can you objectively assess that? Well, at least the hiring speed will improve. Instead of 3 hours for processing the the application, we will have a much shorter time, so you'll be able to quickly go through the candidates and narrow the funnel. Okay, anyway, great. Thank you so much for that, for sharing your ideas about HR and using models in HR. I know you have many great ideas. We do wish you all the success and in developing AI in HR processes. Thank you. Thank you so much. Well, dear friends, it was our last speaker. Thank you for staying with us. It was around 8 hours, around 5 hours. I'd like to reiterate that it is just a small part of what we do. Oh, Siri decided to talk with me. That's interesting. So the classical stories like scoring, personal recommendations. Here we understand what these models do. These are the models that give us the major profit, as a bank. But it's always interesting to listen about some new, surprising applications. And we tried today to go through some of these cases. You can talk with the guys. They will be very happy to share with you all the information about creating models, about using models in Sber. I wish you a very good evening and the remaining 2 days. Tomorrow we will have a day for society, state and business. We will have a plenary session with the President of Russia, CEO of Sberbank, the President of Kazakhstan. Day 3, it will be an AI Journey Junior, so you can get your kids. It will be focused on specifically on children. So I do wish you